Engineering, Township of Central Wellington, and Colin Baker, who is Managing Director of Infrastructure Services with the Township of Central Wellington.
There you go. Awesome. Great. Thank you. Hey, everyone. So, hey, it's a pleasure to be here today, and yeah, just awesome turnout. So great to see everyone. Yeah, we've got a bit of a project we wanted to tell our story about, and essentially it's using a bioresin to improve structural capacity on a rural road. So this just kind of talks about Township of Center Wellington's experience using this relatively new product from a company called BDT. So just want to throw out some thanks. So Adam Gilmore, who's over there, prepared the presentation with also help from Dave Hine as well, who was supporting the application of this new product. So there we go. So Township of Center Wellington, always like to call a quick survey. So who knows Center Wellington or where it is? All right, we got some people. Okay, we're not too far away, but so maybe you've heard of our major urban centers. So Ferguson, Elora, is that okay? Yes. All right. Anybody been to Ferguson or Elora? All right, good stuff. Okay. Yes, you and I think we had about 1 million tourists last year, so it's definitely on the map, and we've got a lot going on, especially in Elora. There's a lot happening there. Anyway, so yeah, we just an introduction to BDT, so Biodiffusion Technologies, and their Green Roads product. And we basically engaged with them a couple years ago, and it's a technology being utilized to stable road bases and kind of granular materials. It's a technology that uses bioresin that is mixed with base materials. It's all natural. It's plant-based. And we started just some product trials in 2022. We were kind of one of the early adopters, and just, hey, let's see what happens when we spray this on anything. So we went gravel roads. We had some granular A gravel stockpiles that we sprayed, just kind of seeing how it would react and how it would, kind of perform under a variety of conditions, different applications. We really kind of kicked things off. The following year, we went to council in 2023 and got approval to do a pilot, a trial, kind of a base stabilization project. And being a cautious municipality, we're just started with a small section. So it's like, hey, we didn't want to do a whole road, multiple kilometers. Let's start with 300 meters and see how it goes from there. We followed that up in 2024. Things looked good in 23, the results of that part. And so in 2024, we did a full-scale project of just under 2 kilometers along the same road. And Adam's going to talk a bit more about the results of kind of what we're finding. So basically, expected benefits. Increased structural capacity. You guys may have heard of that stiffness. That's really desirable in building roads. So it adds to the overall stiffness of the road combined with the surface. There's sustainability benefits to using an all-natural bio-based stabilization binder. We also looked at there's opportunities to reduce greenhouse gases as well as part of this. So really part of the sales pitch to our council for this one was looking at the life cycle cost savings for this, incorporating this product into our roads, and can we extend the life of not just the road base but also the asphalt surface itself. And there we go. So just some facts about the BDT as well. And I know BDT has a booth here today, and there's a couple representatives from the company here. So if you do have any questions, kind of what their product is and kind of how it works and why it kind of looks like gravy, you feel free to go chat with them. So just a quick overview of our trials in 2022. Yeah, we did some soil stockpiles, some A gravel piles, and you know, it's basically it's a hydrophobic material, so it really sheds the water. You know, for a while there, we were thinking about, you know, we're in the water business at Center Wellington too, so we've got water main breaks through the winter. We've got A gravel just kind of stored outside right now. So we actually took that pile of A gravel, sealed it, and we're just it kind of formed like a waterproof crust essentially on the pile. And you know, we didn't have big blocks of you know, kind of frost when we went to excavate some material out to backfill for a water main break excavation. So definitely, you know, just kind of trying some different things that we treated a low volume, very low volume gravel road. It was actually a dead end section just to see how it would perform over winter as well. And then some shoulder stabilization. So this was a newly reconstructed road, some pretty steep shoulders, and just kind of did an application on the road itself and on the shoulders just to see how the material forms. So again, just trying different things at this stage, and working with BDT and their team and their experts to see what works and you know, what doesn't. So I think with that, maybe I missed the slide too, but just a quick note to our council, you know, was very interested. We have a very, I think, forward-looking council. They're very interested in innovation, right, and what we can do to save cost and what we can do to be innovative as staff. We actually have a strategic plan objective directly on innovation. So really, when we went to council and said, hey, we've got this product that we want to try, you know, and see how it worked, it was seen, you know, it was very well supported when we talked to the mayor and council with this. So yeah, so that was part of the sales pitch, and part of the, I think, success in applying this in Center Wellington was that political support. So I think with that, we'll hand things over to Adam, and Adam's going to talk about the big project that we did in 2023.
All right, thanks very much, Colin. Hi, everybody. I'm Adam, and I drew short straw clearly on this presentation. I have to talk about all the technical stuff, so I'll do my best. So full disclosure, so Colin mentioned Dave Hine, and so Dave Hine pulled together a lot of this study and the data. And we, many of you in the room maybe know Dave Hine or have heard of him, but we refer to him as Genius Pavement Dave in Center Wellington. So he really is, the work that he does is really amazing, and we're fortunate to have him helping us out on this project. So the 8th line is a rural road in the township. It's quite well traveled, so average daily traffic of about 1,000 vehicles and a high percentage of truck traffic. And those trucks are going to gravel pits that are located on the 8th line. So loaded, unloaded gravel trucks. So the road was in quite poor condition. The pavement has failed, and it's at the end of its life. And we had a capital project to repave the road, but we know that in the past, this pavement really hasn't performed well. It's degraded quite quickly, a lot of rutting, and so not maximizing the useful life of that pavement. So we're thinking of, you know, what can we do here to try and strengthen this road and get more life out of the pavement? And so we turned our attention to the road base. And so looking at the characteristics of the road, you know, about 80 mils of asphalt pavement on average, 175 millimeters of base with variable fill, sand in some areas, going through kind of swampy topsoil parts in other areas. So not a great road base. And how could we be innovative in trying to strengthen the road base without reconstructing the entire road, excavating the material, bringing in fresh granular? And so we really saw BDT bioresin. We saw an opportunity here to try it out, kind of scale it up and take it a step further from the trials that we've been doing that Colin went through. And really the key question here is, you know, can it extend the life of the pavement by strengthening the road base? So before we got started, we wanted to have a really good baseline to which we could compare the treated road segment. So Dave Hine, with Good Roads and the MTO, had been testing this new, this fancy new equipment from New Zealand called a multi-speed deflectometer. And what this is, it's a deflectometer that's actually inside a truck tire. So a truck drives down the road, and this tire is deforming, right, as it's going. This is a loaded vehicle. And so then the deflection of the tire is actually being used to calculate the deflection of the pavement. So the advantage of this is you can collect really high resolution data really quickly. So you can drive down the road, you can collect readings every 10 meters, and then that kind of gives you the pavement deflection under load. So we went out and we did a survey of the segment that was to be repaved with this multi-speed deflectometer. And then we found, a lot of variability in the deflection, but generally, it was a high deflection of the road, so greater than 2 millimeters, and average about 2.8 millimeters. And we found this segment where there was significant deflection, and the deflection was quite uniform. It was a 300-meter section. We thought this is a great section to trial this resin to see what it can do in terms of strengthening the base. So how we did this, I'm going to show you some photos to illustrate this in a second here, but the general sequence is first we went in, pulverized the existing pavement to about a 6-inch depth, and mixed it in with the granulars so that we had kind of a uniform media. We then graded it for store crossfall, added about 50 mils of fresh granular A, and then we applied the bioresin. So this is done by a truck with a spray bar, and so it drives along, sprays the resin onto the surface, and then we have this additional step of mixing that treated material. So then we go back in with a pulverizer and try and mix it all up so that we can have that resin come in contact with as much of the mixed granular material as we can. Finally, once it's applied, grade it and compact it, and then pave over top of it. So here's what it looks like. We've got our initial pulverization step, then the bioresin application, so it just comes out like water. It is kind of diluted, and the dilution is kind of tailored to the application, but looks a lot like water. We then repulverized it to mix in the bioresin and graded it, compacted it. And so after we treated that 300-meter section, so the question is, well, what's it doing? How much harder is the base getting? So right away, Dave and his team went in and started with a lightweight deflectometer, testing that treated section 1 day, 2 days, 3 days, all the way up to 8 days after application to measure how it was strengthening over time. Here's a lot of information on a couple graphs here, but I'll break it down for you. So the scatter plot here, so you see the red line, that's the 2.8 mils of deflection, so kind of the baseline deflection that was occurring before treatment. Then the busy series of plots here, that's just the testing between day 1 and day 8 after the treatment. And then finally the black line is the deflection after paving the treated section. So the key here is over time, over that 8-day period, the base was getting stronger, and the number is about 18% stronger on day 8. The reason for this is, so kind of similar to how concrete hydrates this resin, as the water evaporates, you're left with just the resin, and then the resin's bonding the granular material together, and that's where you're getting the strength from. So increased strength in the base over time, and definitely increased strength after paving. And then we followed that up with testing a year later. So this past summer, we went back into the 300-meter trial section, and we tested it again, and it continues to get stronger. The deflection continues to decrease. So we started from a deflection of 2.8 millimeters down to below 0.5 millimeters. So part of this is the base continuing to strengthen, I think, as all the water evaporates. Some of it also, as Dave highlighted for me, is the oxidation of the asphalt layer. So the asphalt itself is getting stronger over time. So tough to kind of back out which one is which, but the key here is that the road is getting stronger over time. So in conclusion, the bioresin, I think we can say with some certainty, did improve the structural capacity of the unbound granular base. The number that we have is about 18% after 8 days. And applying that asphalt pavement over top further reduced the deflection by about 50% from 2 millimeters to actually a year later, less than 1 millimeter. So we're very interested in the results here. We've presented these results to our council, and they were quite interested in it also. And we've presented a bit of some figures to them in terms of life cycle costs, which are still very preliminary. We didn't include in the presentation, but I'd be happy to talk to you about that maybe one-on-one after. But there's definitely a business case there for using this treatment to strengthen road base. And so we want to scale this up. So this past summer, we have another section of the same road. We've paved 4 kilometers of it, and we actually treated about almost 2 kilometer segment with the bioresin. So we went from the 300 meter trial last year to now a 2 kilometer trial this year. Few refinements to the application process just to make it a little more efficient, but generally the same method we used in 2023. And we're in process of collecting data. So I was kind of hoping we'd have a more fulsome data set to present to you here, but we're still in process of getting that information together. But again, we've got kind of the 2 kilometer trial segment, the 4 kilometer segment, where we've got some base case information that we can compare to, and then we can monitor over time the impact and the benefit. So our next steps, we'll continue monitoring the 2023 trial section. Like the big question is, how does this stuff do over time? You know, you got freeze thaw cycles, and so, you know, is it maintaining that strength over time? That's something we want to know. We'll be collecting more data from the 2024 segment, and we are going to be looking for opportunities in 2025, other paving projects, I think, to try this stuff and continue using it, because again, we do see value in it. Thanks very much. That's everything I have, and happy to answer any questions you have. Thank you.
Thanks. Yeah. Any questions for the gentleman? Oh, we got one right here.
Just wondering what the 8 days was significant. Like, as far as leaving it to cure for 8 days, did you do longer, shorter? Was that recommended, or was that just the number you picked every year?
The only significance of the 8 days was that was the longest we could put off our general contractor from paving the road. So we had a general contractor we'd hired, and we were kind of working outside of that contract. So we just said, you know, they had their schedule, and we said, you know, can you hold off as long as possible to pave the road? So 8 days was the time frame, the window that we had to test it. We didn't want to wait too much longer than 8 days, because then we didn't want a bunch of vehicle traffic driving over it and perhaps, you know, breaking up the section that we treated. But yeah, it would have been interesting to maybe even test, you know, longer than the 8 day window.
Oh, that one here. Right here.
Oh, yeah.
So I did not see a significant difference in elections, control versus treated. Did I miss something there? I was just curious. It's going to be good.
Yeah, so I mean, the number we were using is 18%. That was normalized, so that was 18% stronger than the pre-treated condition.
Anybody else? Oh, we have one back here.
I have 2 questions, Adam. Did you have traffic on it for those 8 days then while it cured?
So we did not. So we had to, that was one of the improvements that we made from 2023 to 2024 application. So 2023, we did a hard close of the road while it was curing, just because there was some uncertainty about when it was going to be ready to drive on. And it's also very weather dependent. Like, you want to be applying this stuff in warm weather, dry conditions, because the key is getting the water out. So we did, in 2023, we did not have any traffic on it in the 8 days. This year, actually, the results were much better. I think we had, we were driving on it within 24 hours of the application.
Do you know what the application rate was of the resident?
Yeah, in terms, that's something that I think the BDT folks could maybe help you with. I know that, you know, they kind of, it depends on your mixing depth. We elected to do 6 inches. I think now they're doing 3 in some cases, and they kind of tailor the application rate to the mixing depth.
Anybody else? All right, well, thank you very much.
Thank you.
Here's a little presentation for us. Thank you. One for you. Thanks, guys.
Thank you.
Okay, one reminder, if you have any questions for our keynote panel, to write them down and submit them to the registration desk up at the front and before this discussion at 3:15. Now, our next presenter, telling me some good stories at lunchtime. We would like to, you might have seen him, you might have seen our next keynote speaker on the Good Roads podcast. Brian Keierleber joins us from Buchanan County, Iowa, where he's a county engineer, grew up on a ranch on Rosebud Indian Reservation and graduated from South Dakota State University with a bachelor's degree in civil engineering. He is currently the past president of the National Association of County Engineers and is currently the president of the Iowa County Engineers Association. Many municipalities responsible for low-volume roads share the same pain points, and Brian is going to look at bridge construction, maintenance, and cost-saving strategies. Please welcome Brian Keierleber.
Thank you. Thank you. It's truly a pleasure and honor to be here. And we'll start out with this first one. This is a 132-foot long, 3-pin wooden arch bridge. Now, it's not economical unless you can get into the right grant programs. A little bit about Buchanan County. I have 963 miles of roads, or 1,550 kilometers. I have 260 bridges over 6 meters. I have 34 bridges now built out of retired railroad flat cars, and I'll try and cover that in a little bit of detail in a little bit. I have 2 cast-on-site slabs. I've got 6 GRS IBS abutments. That's fabric bridge abutments, where you use fabric and layers and do your substructure with fabrics. I've got 3 ultra-high performance concretes, plus I've got a fourth one where I've used the slabs tied together with UHPC. I've also got a UHPC deck overlay. I've got 3 glue laminated bridges, a modern glue laminated, not the old nail laminated. I've got 3 internal carrying concrete bridges. I've got 3 buried soil structures. And I've got 3 more rail cars ordered for bridges. In the county, there's 21,000 people and 372,000 pigs. Some of our bridges were old. These were bridges that I ended up replacing. Upper left there, that bridge was built in 1870. The lower left that's going for the ride with the Chinook helicopter was part of a river crossing. It was built in 1875. The lower right one, the bowstring arch, that was built in 1872 and moved there in 1891. I was wondering what they were feeding the horses that they couldn't cross that bridge. We were still using it in the 1990s when I got to Buchanan County. I've been blessed with many opportunities, and some of them is around like this. So I was sitting in a presentation in Kansas, and they had the same issues that many of us have. We can't afford all these bridges. So the Kansas DOT hired the University of Kansas to do a study. When can I economically close these bridges down? They didn't get the answer they wanted. They got maybe the reality, but not the answer they wanted. If you have a 3-kilometer detour and there's 1 car using it, you can't close the bridge down. 1 car a day. Even if it's basically, my answer is, if it's 4-mile detour and you got less than 10 vehicles a day, you cannot economically close that bridge down. Now, you got to take into account the length of the bridge. If I'm remembering the study right when it was presented, this is a number of years ago, that was on a 70-foot long bridge. And remember the comments we were hearing just a little bit ago. We can't afford all these bridges, you know. And I've got the same thing going on. Just a week ago, roughly, I was interviewed the gentleman by the local TV station. The gentleman that spoke before me was from the DOT. Says these counties can't be out there spending $1 million on a vehicle carrying 25, 30 vehicles a day. Well, the reality is it depends on what kind of ag loads you're getting on those. They can't run them all around. So we got to come up with better solutions. And I like this picture because I had to close the bridge down. We were getting ready to replace it, and the farmer came down there and started chewing on me because I should at least wait till he gets his crops planted. Well, he's not supposed to be crossing it anyway. And this is part of what's going on. This is what they call a 12,000-gallon liquid manure tank. Well, that is roughly 48,990 kilograms of pig manure. This is the one I commented on a little bit earlier to Halil. This is the one that, this is Belder's new 2,850 bushel grain cart, which the great weight of the, if it's beans, it's going to weigh roughly 15,400 kilograms. Well, I happen to live in northeast Iowa, and there was a movie that came out a number of years ago, Field of Dreams, and there was an expression in there that says, if we build it, they will come. Well, my turn on that one is, if they build it, they're going to come. And the overloads have an accumulating effect. Now, this is one of those days I had two people on the counter waiting to see me, and a gentleman in my office, and get to the third guy and says, Brian, I'm sorry to tell you this, but that bridge over by me's got a funny sag. Well, this is what was going on. Yeah, and that was a combine that got away. Not all of them get away. And if you notice, those are two anhydrous ammonia tanks. You poke a hole in one of those tanks and take one whiff of that, it fries your lungs, you're dead. And the bridge was posted at 9 ton in this case too, and they always crossed it before. This is the one that gets me. If you were sitting in the cab of that tractor, what's going through your mind? It's a long way down. This one just happened a couple months ago. Notice the postings on there. It's 11-foot height, and it's also posted for about 14 tons for this particular load. Yeah, the tractor trailer was more than 14 tons. And it's on tracks, that won't hurt anything. Yep. And it doesn't matter what logos are on that either. Now that happens to be a pin-connected truss. Now, this happened on the interstate in Kansas a few years back, and I'm not sure what they were trying to prove, but it is a new way of closing the bridge off. And this is one of the key things you don't want to do, and this here's kind of the purpose of this is don't put asphalt over top of your concrete bridge decks. Asphalt's permeable, so the road salts get to go through there, they get to stay wet year-round and work year-round. And so we started doing some bridge deck overlays. In Iowa, they had a type O mix, and I'd worked prior to working in Iowa for the past 37 years, I worked in Oklahoma. We were doing deck overlays using the Iowa Special. We started mixing super plasticizers in the type O mix, and that's the way we're doing our bridge deck overlays, and this is starting on doing that in 1999. It now became the state spec too. Some of the other things we're doing is on these deck overlays, you can get the salts going through and getting underneath your deck. So we're doing epoxy injections on our bridge decks where you're having trouble with the overlays that way. We're trying to come up with ways of stretching the lives on these bridges out and bridge decks patching too. But what we're doing before we do the patch, rather than get to the point of doing patching, is we're trying to use sealers and seal off the concretes. And somebody mentioned Pete Taylor a while back, and Dr. Taylor and I have, Dr. Taylor put on a presentation on the different materials and the different, trying to seal the concrete decks. And the substructures can need repairs too. This is just an example of trying to repair the piers on this one. This bridge is still in place, and it's about a $5 million bridge. Now remember, I have 260 bridges. My annual allocation for federal bridge funds is a little less than $500,000. If that's a $5 million bridge, I have 260 bridges. It'll take me 10 years to get enough money to do that one bridge. And so repairs are essential. Pictures of the repairs on that. I'm going to fly through a lot of things, but sometimes there's no good answers. And this is what the road salts will do. I highly suspect, this was not in my county, I highly suspect that they built this bridge on a rock road and then they ended up putting chlorides on there, then sealed the surface and started putting chlorides on there with black steel. And this is Davis County. We talked about the heavier loads. This was a deck overlay that was only done about 4 years ago, and something's breaking that deck overlay up, and they're blaming it on the heavy ag loads. Yeah, we come in and we've posted piling before. That's a prime example of what you're doing, trying to strengthen or extend these lives out. But and even on my concrete piling and such, I'll end up deterioration. And you can see the casement off the H piling's rotting off. And so we're coming back in and doing repairs on the stuff. And that impacts the way I'm doing some business, because if I got to come back in on a bridge that I built and start doing repairs, I don't like that idea. We've got what they call in J standards in Iowa, a lot of them. In this case, it's steel beams, but I've got some concrete beams where they're built in the 1950s and 60s on wooden back walls and wooden piling. Well, guess what? Those wood piling are all trying to rot out now. So what we're doing is we're cutting out the bad spots and encasing them. So that's a full encasement on that abutment. And these are pretty economical. This is kind of the old things I was doing. But we're really working more towards cut out the rotten parts, put some rebar in through there, drill holes right through those wood piling, put the rebar in, and then pour it back. And here's the type of hanger he was using to hold his forms in place. Wrap it around your wings too, so that way it can never kick out. Gives you good strength in there. And this is an example. You see what it cost me was $12,000. I hired a contractor, local contractor, good hard-working guy, to do that, and then I paid for all the materials. And we've done that with piers too. 3 pier encasements cost me $17,300. That's an example of taking an old timber stringer bridge with the piers rotting off and encasing them. This is one we did just not that long ago again. In this case, we actually used fiberglass rebar, but the contractor was not that excited about the fiberglass rebar. And I think he was having some trouble with it cutting his hands. Yeah, and it doesn't matter whether you're box floors or not, you can come back in, repair them up. Yeah, this is a example of piling extensions. I think they raised the bridge up over the years, but that seems like a long way to have raised the bridge up unless they end up cutting some of the piling off. And adding in a pier to eliminate the postings on that structure. One of the things we've done a little different, and I seem to have skipped it, is we have 34 now of our county bridges built out of retired railroad flat cars. So I take 90-foot railroad cars. When they retire them for various reasons, I'll go to the salvage yard and buy the rail cars from them and turn them into county bridges. That's what they look like. And here's what they look like to us. If you look, what you've got in essence is a big box beam there with the deck on it. I tried to address the cost, and I think these are pretty up to date. $22,050 is what my last ones were costing me for the 68-foot. The 89-foot don't cost a whole lot more because the big difference is the trucking on them, because they're coming out of, for me, they're coming out of Kansas City or St. Louis, where the big rail lines come together. So again, they're flat cars, not box cars. This is an upside down version. What you're really dealing with there is a deck with a big box beam running down the middle of it. This happened to be pulp cars. They got a little belly in them. They've also got some weep holes, so we put P-rock in there, level it off, and then cap it off with asphalt millings. If I'm using the full 90-foot car, they do require a pier, in my opinion. And from our load tests, I'm good. I've never built one without, but I do have pictures in this presentation of one in California where they used the full 90-foot car, did not put it in. It's on a logging road. Loggers historically run heavy, even if the signs aren't there. And this is a 20.7 meter rail car you can see out here. When I buy the rail cars, I specify cars designed for 80 to 100 tons. So these cars are built heavy, and I like to use this expression too. The military will put 2 M1 tanks on a railroad car. An M1 tank only weighs about 71 tons. So we should be able to handle most of the loads running down our highways. And you can see this is Iowa State again doing some load testing on this particular structure. They've got the stress strain gauges up. Here's a chart of what we were, and you notice I'm less than half of what the allowable stresses are. Rob Connor is a professor at Purdue University, and I'm flying through this stuff because I got a lot of stuff here. At their Bowen lab, they brought a car in, loaded it up, they fractured the outside members, and it's still loaded to 190,000 pound point load. Various types of abutments. What are we going to use for our substructures? And I'm not beyond using the old concrete abutments or new concrete or concrete stub abutments. I've got some GRS, IBS, or whatever you got locally, you can continue to use. That's what the abutment looked like when I put the railroad cars on it in about 2003. Looks the same today. It saved me some money. One of the things that's really happening that is vibratory H-piling drivers, and I don't know how common they are here, but boy, that is the slickest and safest way to do it. Now, I don't own one. They're about $120,000. But I can hire Clinton County to come up and drive all my piling in a day's time. I've got a bill of maybe $3,000, $4,000. Why would I invest $120,000 if I can get by $3,000 to $5,000 a year for hiring somebody else to come up and do it? There's various counties in Iowa that now have the vibratory H-piling drivers. One of the things, here we are as engineers and we're purists, you know, is how do we know what they truly carry for capacity? Well, they also developed a drop hammer to hook on their excavator. They can go tap it with the drop hammer and see what they're getting. But I visited with their engineer and he's kind of getting tired of doing that. He said, Brian, if it sits there and vibrates for a minute and doesn't move an inch, we're good. Stub abutments with sheet piling. My guy said, Brian, you know, the shortest piece of life on this is going to be the H-piling, or sheet piling. So we've started galvanizing the sheet piling. But it's a very good way of building back walls, simple. I'll show you some H-piling piers too. You can see the galvanized sheet piling on this particular bridge. There's reasons I got 34 of them. Most critical, supporting the abutments. Where you're actually sitting these cars is on the bolsters, which is where the trucks, the wheels used to mount. So that's where the car is really designed for. That's where its strength comes from. But if you don't support the outside edges on that, they will rock on you. So yeah, it's key that you do that when you're building this. You can see where I've got the neoprene pads in there and shimmed it up. That's how I transitioned from my back wall to the deck. To weld the steel metal plate on there. Tying the cars together, bolted directly every 4 feet, or bolted with concrete and number 8 bars. That's my favorite, and that's my operator's favorite. My bridge crew is currently a 2-person bridge crew, and they can build me one of these bridges in the summertime. And they by far prefer, I can show you some other bridges that we built, and I had to provide them help on them, but they by far prefer building with the rail cars than they do the wood or the concrete that we've done. And this is what I mean by putting a sheet of sheet piling in between, pouring the difference. Sheet piling is almost 16 inches, so I'll put the cars together with that channel on the outside, set the sheet piling in there, bolt across, put some number 8s in the bottom, number 4s on the top, 5s on the top, and fill it full of concrete. And this is what I mean by bolted together. Type of decks, asphalt millings, rock, or an asphalt slurry. And I've never done the asphalt slurry, but I've got pictures of it from Pennsylvania. This is what I mean by asphalt millings, putting them on. This is road rock. Patching holes in the deck, and I've got to change on this a little because we've been using the non-woven geotextiles, and I've been doing this since 2001. I'm starting to have some problems. I'm learning that the birds go underneath there and will pick at my tar paper and poke holes in the tar paper, and then I'll get some leakage. So it's simple. We're starting to weld plate on that. How did they deliver them? These cars happen to be purchased out of Richmond, Virginia. I was contacted by a guy in Richmond, Virginia. I had 200 cars, wanted to sell them to me in groups of 50. That was a little more than my budget would allow, but I contacted several other counties and we bought a bunch of them, but they trucked them all the way from Richmond, Virginia to northeast Iowa. And that's in the vicinity of 900 to 1,000 miles, so you're talking 1,600 kilometers. And why did they do that? They're active cars, because if they're going through a rail yard, the rail master in that yard could say that car needs to have some work done to it. They could pull them off the line and do the repairs to the brakes or whatever. You can see the grab holes in there. That's what you got to plate off. The reason I took this picture is because they failed. The cars are supposed to be prepared for me. Well, they failed to cut off the jacking port there in the center so the cars wouldn't slide together decent. All metal piers. What those are is HP 10 by 42s driven in the ground with an HP 12 by 57 sitting on top of them and a C16 cap on top of that. That's what I'm using for the abutments, or the pier. It's a simple, simple way of building the pier, and it's very effective. Placement of the cars. They slide real easy. So I'll order cars, and they may deliver, for next summer, they may deliver them this fall. I'll throw them in the road ditch and then drag them down the road ditch next spring when I get ready to build with them. And in this case, we had them all stockpiled. We had a couple cranes there, and at this particular time, to set the cars. My crane was a little too light, and so by me having my crane on one end, theirs on the other, I could get by with a lighter crane. And if you really want, you can set them. This is pulp cars being set with an excavator and a 17-ton link belt. Otherwise, you can see them swinging the cars into place. GRS IBS technologies. This is something that's really being pushed by Federal Highway Administration. And the state of New York's done a lot of the GRS IBS. It was really developed in Defiance County, Ohio. And there's a time and a place for everything. It's a very practical answer. Now you notice on their designs, they use CMU block. I know my guys, they're good equipment operators, but I can't imagine them stacking CMU block. So what we did is we used riprap, or we stacked it on a 2-to-1 and then faced it with riprap. And I've got some pictures of doing that. There you can see what I mean by the fabric being stacked at a 2-to-1. Then you use what they're referring to as a burrito wrap back in, and the next layer comes on top of it. Those are 8-inch lifts. Then you pack that granular material in the 8-inch lifts, and you do another lift of fabric. So what you're really doing is you're spreading that load out, much like they were talking about the soils earlier and the strength on the top. Spread the load, that's what you're doing here. And there we are placing the riprap. And I had somebody say, well, don't people get excited about your equipment being in the creek? And I said, it's a whole lot better than the farmers driving through the creek permanently. There we are swinging the rail cars on there, and you can see how I tried to tie the riprap together with some flowable mortar or concrete on, not truly flowable mortar because that erodes, but concrete on the top. And you can see the completed superstructure. You see the barn in the background there. There's the finished bridge. And that is right at 28 feet, which I won't try and convert to meters right now. This is what we did this summer. This is 2-span, and I did have a live camera feed on it. That link does not get me to that live camera feed anymore. They're not supporting that, but I got another link that does. And this is that one completed, so that's about 41 meters long, built by my crews. Now you notice the pier out there and the piling. What we did is we capped the dirt around there, drove the piling, poured the cap on top of the pier on the piling, then excavated the material back out. And so there is the Iowa DOT studies, Iowa Highway Research Board, Iowa State University's got some information on that if you really want to go into detail on using the railroad car bridges. And I should give you a little background on that. The technology was actually developed by Caltrans in the 1960s to use when they had earthquakes to get their interstates open faster. And they were the ones that started working on it. So there's still counties in California that have a bunch of these. Eastband 140 is a design tool to help you with steel beam bridges to do some of the design work. So you can sit down and maybe you're just using it even as estimating, but it'll go through and get the lengths and sizes of your beams. There's some information you put into it. We got involved. We were the first ones to really do this and started using that. This is me removing the old bridge. Now in this case, I'm getting down too close to rock, so I had to actually drill into the rock and then encase that. And then the standards called for me to put bentonite around the top too. So I get some movement in my abutments. It's integral abutments that way. And this is, I've got more than 2 guys working on that. This is my bridge crew out tying in. You notice I'm using the galvanized rebar. This is a paved road. I'm a big fan of using the galvanized rebar. My assistant's not, but it is a little more spendy, but I believe in the long term it's well worth it. I've got some studies from New Zealand and such that says it's dramatically better. Every day is a learning experience, and we're all learning. But you can see this is kind of thing we've done with our rail cars, in essence. And then bolted, these are actually my two guys in the bridge crew. And I did bring in some other guys to help them, especially when it came to tying steel and decking it out. And brought in a contractor to help pour it too, because I didn't have the pump or the conveyor. Yeah, missed what it took. We ended up scooping the snow off it twice before we got that bridge built that year. We were getting snows in October. This time of year, we were getting snows. So that can happen. We used an MGS guardrail system, which is crash level 3 tested, which is a hot issue in a lot of areas. Yeah, it's a ribbon cutting on the bridge. That's press brake tub girders, and this is another one that we used on the GRS IBS. This is a really new technology that's being developed in an economical way. I've seen some bridge bundling done in Michigan and other places, Pennsylvania and Michigan, where they've come in as the low bidder using the press brake tub girders. What it is, they take steel plate, which is the most efficient way of making steel. They'll take the steel shape, fold it into a box shape, put shear studs on it, and that becomes your bridge beams. And there are several different designs being utilized. This is examples of a couple of them. And this was Adirad Azanami when he was working at the University of Nebraska-Lincoln, and he's with Florida International University now. But this was the design method he was usually really working on. And again, they put shear studs on the top of that too. And this is the one that was being worked at West Virginia University with Dr. Carl Barth and Michael Barker's with the University of Wyoming. He was involved with this project too. This is, again, using the GRS IBS technology. So basically you drive your sheet piling, you come in behind there, excavate, put your fabric in, bring it up in lifts, and put it in. Now this is set in the tub girders. The contractor had a choice. He could get them precast or cast in place. In the States, and I think it's pretty broad, the contractors generally want to do all the work themselves. Why do I want to give somebody else money is the feedback I get from them. So they'll do all the forming and pouring in place. And that is a press brake tub girder sitting on GRS IBS abutments. There's no H-piling underneath there. It's the fabric in layers and bringing them up. What we kind of talked about in the past led to this one. And this happens to be a 200-foot structure built with galvanized rebar, galvanized beams. And the big difference here was galvanized H-piling. The bridge I built downstream from there in 1996 was the one I showed you the picture where the concrete encasements are rotting off. So why do I want to go back in and build a bridge where I've got to come back and do repairs to it? So we galvanized and coated the H-piling, and Iowa State would then start doing some studies on this too. They said, Brian, you really didn't help yourself with the paint system on that, though other people would argue that. But the galvanizing in itself will get you over 100-year life out of these H-piling. And so here we are driving the galvanized and coated Cardinal Red H-piling. Cardinal Red, it's just like blue for today. Cardinal Red's Iowa State colors. And what happened to me is I had 3 50-year flood events when I was trying to build this bridge in the fall of 2018. And it gets awful hard to build cofferdams when they're underwater. So because of the fact that I didn't have to encase it in concrete, I didn't need the cofferdams. What this did for me is I had this bridge open on December 24th, 2018, where it probably would have been July timeframe of 2019 when I would have gotten the bridge open. Huge, huge savings to me, not having a paved road closed for that kind of a period of time. And you can see where, yeah, Buffalo Creek kept coming up, and the concrete had to keep running for cover. And I have seen their excavator with water above the floorboard. But when it went back down, they could get back to work in there again. Again, setting the galvanized steel beams. One of the key things is most of our bridge designs, if we're using any standard plans, were designed in the 1950s and 1960s when labor was cheap and materials were expensive. Nowadays, we need to rethink what we're doing And we need to do a simple span, dead load, continuous span, live load designs, and make it simpler to, rather than having to cantilever these beams out and tie them together, set them on the abutments and tie them together on the abutments. Pouring the concrete, again, this is one of those times when we're there getting the snow in there before we're getting the bridge done. Why galvanize the rebar? And this is what I was referring to earlier. Life cycle analysis of epoxy-coated galvanized and solid stainless steel enforcement and high chloride exposed decks in the U.S. has shown that galvanized steel has the lowest life cycle cost, according to this one. The service life of galvanized decks is 100 years compared to epoxy-coated deck of 55 and solid stainless steel of over 100 years. Well, stainless steel is quite expensive, but yet they're using it fairly regular on bridges now. There was a bridge on the I-74 bridge, and that used the stainless steel. And I know some of the DOT engineers real well, and the stainless steel wasn't that expensive, but those prices have significantly increased lately too. I see the discussion on buried soil structures. I've got 3 of those out there too. They are definitely an economical answer in the right places. And this one was a prime, it's simple to construct, is really the key. You can see the footing we had in here. Now, we did drive piling on this one, but I thought, why not, if I'm in the right environment, why not go back in, cut off the old wood piling, excavate down a foot or 2, and encase that old timber piling in my footing. If you go down below the ground line, that wood piling's as good as the day it was driven 50, 60 years ago. And it's a huge cost savings. And this low profiles are possible. In this case, that's a 40-foot span in there. 12.2 meters. And this is what I was referring to about simple. This is this guy's first buried soil structure, but basically you can assemble them, swing into place, and set them out. I heard the discussion of wildlife crossings, and this is actually an overflow bridge beside another old bridge. And so it was just this perfect environment for that. It worked excellent for me. There is a new grade of steel coming out too, and this is Nucor's grade 65 steel. It's 30% stronger and 5% more cost. And we partnered with Nucor and built one of the bridges with that. Though I really learned I needed to design it a little different. I really want to design it for non-composite action and put an all-metal deck on there. And precast slabs. Now, there's some states that have put a moratorium on building because they're having some issues with some of the precast, particularly in Illinois and Missouri. But they're working on some designs to correct some of those issues. Compacted concrete on GRS. So here we stacked the fabric on a 1-to-1 slope. Now, the guys, I asked them, can you do that? And they said, yeah. And then I went off to a meeting. And so what they ended up doing is taking pins, driving through the fabric, setting 2x12s, and then they are 2x10s, and then they backfill the 8 inches up against that to get the different lifts. Then what I did is I put number 4 steel at 2-foot centers, and I probably should have gone a little tighter, and then packed roller compacted concrete on the sides. That's probably the only bridge in existence that's using roller compacted concrete for the abutments. And that's on a 1-to-1 slope in the face. Again, the GRS IBS, this happens to be one that we're using the precast slabs on. Now, this is a study that was being done in Wisconsin, and they're trying to compare the costs. In some cases, they cost more. In some cases, they cost less. The secret to that is use the sheet piling instead of the CMU block, because they were building cofferdams to be able to build their abutments. The sheet piling becomes your cofferdam. And that's a completed bridge doing that. UHPC, this is another interesting material. We'll get in, I think I've got some of the details on that. Little background, initial beam design, but I do not have time for all that, so I'm skipping through. This was the first design developed by the Federal Highway Administration using the UHPC, ultra high performance concrete. You notice the deck is only 3 inches thick and has no mild steel in it. And they actually built this prototype, and test it, but they found some concentrated stresses and some issues. So they redesigned, and this was the final design they came up with. Now, this is work being done about 2006. We were trying to get a fabricator in the States willing to build these beams with the UHPC, and we couldn't find one. And Lafarge says, well, we'll do it in our Winnipeg, Canada plant. Boy, that's an education and a learning experience for me. And that happens to be the Jakeway Park Bridge, which was truly done in 2008. Well, we were contacted by the Korean Institute of Construction Technology about 2015. They wanted to partner with us on building a bridge with UHPC. And so we go to a letting. First we had a pre-bid trying to get contractors interested. Nobody bid it. My assistant goes, Brian, we could do that. I said, I know we could. So we ended up building the forms out of timber and building the UHP 50-foot long span, UHPC. And this is the mixing proportion in the process. This is my assistant, Alex, who is also a licensed engineer. He built the forms, and then we constructed, set it up in our yard. We bought, just like with Lafarge, this is placed in the mix in 2008. What we did is, this is us placing the mix. We got a fertilizer elevator. We'll make it easier. We'll work from the ground rather than up on top. And Lafarge putting in the steel fibers. They're nasty to put in. If anybody's ever dealt with those little crazy things, it's not fun. Well, again, the fertilizer spreader, and we put a grate on there because you got to break them up or they'll come out in balls, clumps. And this is my guy, he's doing it. On this picture, notice he taped his pockets shut because those little things will seem to crawl in your pockets with you if you don't. This is pouring up in Winnipeg and steam curing in Winnipeg. And so what we did is we rented a ground thawing machine. We had we ran the ground thawing machine, ran sprinkler hoses underneath there, the hoses from the ground thawing, and put it and blanketed them off. What's interesting is you'll notice that broke at about 21,314 kilograms per square meter. Now I should have broke that down different, so that probably isn't quite as accurate. But we had over 30,000 pound compressive strength on this concrete. Then we had the post tension, and I was just telling a story earlier, and I am truly running out of time, but I'm going to keep flying. That Brent Fair is a structural professor at Iowa State and head of the engineering center there. Brian, how come you county engineers are so opposed to post tensioning? And I told him, because we don't know how to do it. Well, I've got some special operators around there. These are heavy equipment operators generally. We'd rented the equipment, and before I ever saw the equipment, he had it all figured out, knew what stresses and everything needed to be. And you can actually notice the red paint on there. That way you know if anything's sliding. But and then you can figure the tensile strength. You end up like 10,000 PSI. Spray it, and then stretch them out from there. UHPC deck overlay, and I had, again, this is about 2018, just finished the other one, and a gentleman from the DOT calls me up and says, Brian, are you interested in doing a UHPC deck overlay? And I says, yeah. He says, well, Lafarge will donate the materials. We've got a $50,000 budget. I said, yep, you're going to give me money and materials? I'm definitely in. And he said, picked out the bridge, and this one happened to have a 5% super on it. And that was one of the things they were trying to do, is to use UHPC, which is self-leveling, self-consolidating on the super. And so Lafarge worked with the mix, and we did the deck overlay. We ground it, prepared it. Wire mesh. They were thinking they can actually strengthen the slab bridge, which was built in 1954, by putting in the steel on the top where negative moments are. This is poured. We learned it works better if we go crosswise, but now this was before there was any equipment developed. This is actually the first UHPC deck overlay in the Western Hemisphere. And since then, they've developed equipment to do this rather than the vibratory truss speed. Texturing after the grinding, grooving, and that is the finished product. In Europe, they build many timber bridges, but I haven't found them really come in too economical yet. But I had a gentleman from South Dakota that wanted to partner with us on building a 70-foot long, 40-foot wide glue lam bridge. And so if you're going to do that, if you're donating me the materials, I better do a little extra. So we actually, on our concrete, what we did is use textured forms and colored the concrete so it looks a little better. And this is constructing the stringers. This is our glue lam beams when they came delivered. They also notice everybody's already wearing sweatshirts. It was late in the year and I had to wait for some of the materials. This is the deck going on, and there's all holes there where the bolts go in. Well, what we did is it was too late in the year to use asphalt on it, so we used the epoxy and friction course mix. So it's an epoxy with bauxite aggregates to give us friction. And it soaked up any cracks or anything, it filled them all in. And it was kind of interesting. Well, what that did, and it was actually widened for path too, and I think I got pictures of that later on. So, well, U.S. Forest Products Lab wanted to partner with us then on another project, so they funded me $160,000 for materials for a bridge because they wanted to know on fabric abutments, so we'd had experience of that. Yeah, and so that's one with U.S. Forest Products Lab. I get to the end there, and it says, no, I don't have time to be bothered by any crazy salesman. I got a battle to fight. Notice he's standing there with a machine gun. The point is, we've got to look at this new technologies. We've got to make changes. We can't continue to do things the way we've always done. We've got to look for better answers. Thank you. I think I'm out of time.
Thanks, Brian. That's good. Thank you. Here. Thank you. Thanks, Brian. Are your low-volume roads more at risk than other roadways for safety? To tell us, we have double presentation before our last break of the day. We are joined by Jolene Ingribelli, who is a public sector risk management from BFL Canada. Jolene joined BFL Canada from the municipal community, where she served as an insurance risk management officer for 14 years for a large single-tier municipality. And we have Dewan Karim is a practice lead in transportation group at 30 Forensic Engineering. He graduated from the Masters of Engineering, Civil Engineering from Tokyo University, and he obtained certification from the Transportation Professional Certification Board as a PTOE professional. Dewan is also a part-time instructor for the EPIC Transportation Program. Please welcome Jolene and Dewan. You have your, do you need this?
I don't have it yet. I mean, good afternoon, everybody. Can you hear me in the back? Okay. In case you're wondering what do I have in my hand, so I have a little announcement from our company. We're going to give you a Tiffany's bracelet. So if you just drop your cards during the break, we'll just pick it up end of the day before we end here. So we'll coordinate that. Our presentation is not about the bracelet. It is about the safety and the risk of low volume roads, especially what we do in our firm. All the things that you hear today, what you are supposed to do, how you build, maintain, and operate the low volume roads. If you do it properly or if you don't do it properly, if there is a claim, what happens? And it involves with cars, trucks, pedestrian, bicycle, anything that moves on the roadway. One of the difficulty we face in a rural area, as you can see in the pictures, that using the technology to investigate this type of incident, when it comes to our table, someone is asking what went wrong and is there something wrong and so on. Rural area, usually we use, we call it 3D scan, which is what you see in the top right. But most of the time you don't have any space. It's a very narrow road, there is not really enough shoulder, and it's very risky because it's very high speed, especially if it's an asphalt road. So we started to use drone in many cases, and accuracy wise, that might be another day in presentation, we'll do it in future, is very close to the most accurate 3D scanning. So it's probably 1 or 2% difference, but in terms of accuracy in civil engineering, that doesn't really matter in terms of our analysis. When we bring back the data, we obviously analyze in computer using GIS and other tools to understand what's going on that we are looking at. I'll just go over very quickly about obviously why, especially in the rural roads, why this is a big issue. Why do we have actually in a workshop like this? And it's not just here in the US and everywhere, rural roads in focus. And it's a very simple reason. If you look at the statistics, it just tells you the story. It's only 13%, so Canada is urbanized, and we have a lot more people living in urban. Rural is really not the big volume. But if you compare USA and Ontario, population-wise, we have 6% lower, but in terms of fatality, it's the bad news. It's half of the fatality happens in the rural areas. And if you look at the causes that, or the trends, it's in US, they're actually going in the wrong direction in terms of fatality and the crashes you heard about in the news. Last 5 years is actually safety didn't really go in the right direction. It went in the wrong direction after, especially after pandemic. In Canada, especially in Ontario, we have a speeding problem. Almost 70% of the crashes is related to speeding. Very high speed, and we'll show you why speeding is more prominent. But before we give you a bit more details, I just want to give you, and probably you know it, it's one of the focus of Vision Zero. If you heard about Vision Zero, is nothing but, we call it a principle of systematic safety. So we don't just look at where it happened or in one item or another. We look at the whole things together, whether it's speed, whether it's awareness, whether it's forgiving nature of the roadway. It's the functionality and predictability, all these things putting together, how it looks like for broader context and how to reduce crashes systematically. So that's one of the idea of the Vision Zero. Is very new in Canada. It's probably 10 years back, I would say, in max. We started to see these programs, and and now it's spreading in almost like in all municipality and across Canada. In terms of, obviously, I'm not going to spend too much time. What is low volume roads? If you look at key features, we all know that it depends on volume and the type of the vehicles that is going to drive on this roadway. And there's basically three classes. Somebody explained in the morning, so I'm not going to go over the maintenance. So basically, paved roads are nothing but class 3 or 4. Once you hit the mark like 1,000 vehicles per day, that's when we started to pave instead of gravel. Whereas the gravel roads is less than 1,000, mostly not too many heavy vehicles, very small percentage. And obviously there is what we call very low volume roads, which is typically in the range of 300 to 400 vehicles per day. So that's the general kind of division. If you are trying to understand, that's what we do in terms of the surface and the type of the road in low volume. In terms of how they look like, well, paved roads, we know that it's much more stable. The surface is not really like gravel roads. You have a lot more dust in the gravel roads, and obviously in low volume is mostly not even surface treated. It's mostly mud and so on. So you have obviously wet condition situation. You have erosion, you have rut, and all other things happen. In terms of maintenance, which I'll go into the next slide, bit more detail, it's much easier to maintain, obviously. Paved roads is expensive to build, but it's relatively easier maintenance. Whereas gravel, as you heard from previous presentations, it's actually more expensive. And if you look at the lifespan, it's just a big difference between the gravel road and paved roads, whereas low volume, you just literally have to do it almost every year, even though you don't have enough volume or type of the traffic that you're going to spend the money in terms of cost and benefit and return, right? So it's a very difficult situation in a rural area. It is a vast area, it's long roads, maintenance and operational wise, it's not really that easy job that if you're involved with, you know more than us. In terms of safety, you heard about bits and pieces here and there. When it comes to a table, we summarized it. What you're looking at here, key features, for example, traction. It's the first thing it happens, whether it's summertime and wintertime, whether the surfaces you have enough traction to avoid skidding or different types of incidents happen. And based on that, obviously, whether it's dust control or the surface conditions, you will see the defects developed over time. And those defects has an impact on what type of crash that it would occur on those roads. Very simple example, type of the crashes. On the paved roads, we have a lot more high-speed collisions, whereas in the gravel road, you will see a lot of rollovers. It's going over and it's ending up in the ditches. In the low-volume roads, you will see a lot more skidding. You just slipped and you ended up in the ditch. One of the difficulty we have, whether it's signage or pavement marking and so on, so it's easy relatively to put it in the paved road, but it's not that easy for gravel roads, and it's completely different sometimes in terms of how we convey those risks to the road users. So those kind of differences actually matters in a rural road area where sometimes you don't have any lights at night, for example. And it's the same story with emergency vehicle access. Somebody talked about the emergency vehicle and how we plan it in the rural area. Paved road, again, it's relatively easier accessible, whereas gravel, some of the times so we look at our crash data and we see emergency vehicle arrived after an hour. By the time, if it's severe crashes, you could lose your life. So that's the reality. I will give you some examples what we see. It's not necessarily exactly one location. I try to summarize in key types, if you can call it that way. Intersection is one of the reality. The half of the crashes that I mentioned before, half of the crash of that 50%, 25% roughly happens at the intersection. Even though intersection is literally 2% of, if you consider the space, that's literally the 2% of an entire roadway system. But even that small concentrated space generates so much fatality and crashes. And that's unfortunately the reality of rural intersections, and there is a different way to control in terms of engineering, traffic engineering. We try to fix and enhance the safety. One of the easiest way to do is obviously, if you don't have a control, obviously there is a risk, and it's the kind of higher risk compared to when you put the sign. But when you put the sign, whether it's stop sign or yield sign, the location and its sight line has to be coordinated. If you put the sign, for example, is a very common, especially in this region in Cinco, the signs are put according to the regulation, 15 meter, 10 meter, whatever. It sometimes looks like then it's in the right place. But if you look at the vegetation over time, it changes. You lose the sight line, and sometimes it's so small, it's probably 20, 30 meter, and it's not enough for the speed that we just posted. So that creates obviously visibility problem, and it's a very common problem, and it's not easy to maintain those vegetation on the roadside and or intersection corners. If it's gravel road, you can't really put the pavement marking either. All you have is a stop sign, and if it's not even control, then you have no signs at all. So that's one of the reasons it's very difficult to control the speeding or types of the behavior that you will see in the rural area. I'll give you one more example. One of the most fatal crashes frequently happens. It sounds rare, but actually it's not that rare. As an example, I picked here the rail crossing. So it is a crossing or intersection, if you can call it that way. But in rural area, it becomes even more prominent. And you can see the picture. This is actually the drone data and the 3D data that we mentioned before, depending on what we use. And what we do when we come back, we put it in computer, redraw everything. It's like actual situation recreating in computer. We don't have a train, it passed, it's already happened, but we know what is the configuration of the train, what is the speed of the train. We put it in the computer, we see the simulation, and comparing the vehicle speed and train speed and characteristics, when we run the simulation, we actually know why the incident happened. There is not enough time, there is no lighting, there's a warning system for rail. And if you are familiar with the rail and road authorities fight over after the Rail Safety Act came in 2014, it is still very confusing maintenance and operational responsibility. The rail authority thinks that it is the rest of the things. It should be managed by the municipality, where municipality doesn't have enough funding to really maintain this type of situation. So the signage, pavement marking, and other things belongs to the municipality. But there is a point that it's so confusing, and it is expensive to maintain these areas. And whenever we investigate, we see trail of documents between the both sides. Who is doing what? Who will pay for that? And when the Rail Safety Act in 2014 roughly, it was not really still clear who will pay for what items. So that leads to sometimes situation. Obviously, you can fight forever for the funding, but obviously it's being used by the rail or cars or trucks in existing condition. And if there is a deficiency, you will have this kind of situation. And some of them are as dramatic as I have one cases that was settled in a dramatic way. It was in the rural area. There was a severe maintenance lacking. We investigated. I sent a report, and there was like 15 reports against me saying that I'm wrong. What happened in that case? The ex-employee came out in the second day of the trial and literally said, we actually went there and fixed the things overnight. Which is illegal, as you know, in Canada. So it happens sometimes when you realize that that's the mistakes and there is a severe incident happen. It's not common, but most of the cases, what I have seen, most of the time that when we are on the other side, we see most of the maintenance operation done in proper way. So when it's done, and then all the things that you heard today, if it's done proper way, when there's a claim, there's a defense. That's kind of like a simple equation. I'll give you another very interesting, sometimes very touchy and sensitive example. In rural area, there is normal perception there is not much pedestrians. Rural area, high-speed roads or low-volume roads, why do you need pedestrian facility? And it becomes sometimes in a situation like this, if you compare two pictures, one in daytime, you can see it's a narrow road. In nighttime, if you look at the cross-section in the drawing, it's really narrow. It's only 6 meters, 5 meters, most of the cases. And you have the roadside is really steep. So at night, nobody is going to walk on the roadside. They will walk on the paved portion, which is where car is also using at the same time. And if you are thinking, obviously, as you know, lighting is not mandatory in rural area most of the cases, but there is villages, there is First Nations, there is all types of situation, as we know. There are a lot of pedestrians is walking between different facilities and different destinations. At night becomes a default hazard. What is the solution? Well, simple solution is it's what we call isolated lighting. So wherever the higher pedestrian of concentration, lighting is kind of mandatory in this type of situation. Is it warranted? Most of the time is not. So it's a very tricky situation for municipal in this kind of setup to decide what is the risk, especially in this example at night, and what should be the mitigation measures to reduce the number of claims, or in a way it's reduced the number of crashes. I'll give you one more example before I finish. Most of the morning that you heard about paved to asphalt and how those surface and roads are maintained, I'll just give you an example here on the left side that you're looking at. A transition area, we call it. So when the asphalt to gravel, or the other way, gravel to asphalt, obviously you have all these little aggregates spreading over the asphalt area. For example, if you're coming from the gravel roads going to the asphalt area, if it's not controlled properly and treated properly, slopes and transition and all these things, they're best practices. You have a guideline, you have manuals to follow. What happens? You just came out of the gravel road, and there is one of our assistants actually describing what happens in his case. He couldn't brake because there was an intersection. It just so close to the transition area, and there was lots of gravels on the roadway. So it's somebody mentioned in the morning that, for example, sand. If you can put a sand, but once it dries up, sand becomes a lubricant and you lose the traction. So as simple as that, giving the information, treating in those transition area, which is one of the most common areas like intersection, that you will see a lot of crashes. The last example I have on the right side is you heard about potholes, surface defects, and many other types of situation that you can see it, fix it, but some cases you can't actually see it. So for example, if you have just a couple of potholes, and potholes is very difficult to detect in this type of gravel roads, you are looking at a picture which is probably the view of the driver. You also see those potholes. It's snow or it's rain, and whatever reason, it's kind of deceiving. But in the gravel roads, if you're driving there, you probably know it's very common in 80 kilometer speed. You will see that you hit the potholes, and in one case, which I investigated in Alberta, there was 3 teenage girls. It actually was airborne crashes. It hit the potholes. It actually fly over the roadway and landed up in a ditch, and 2 of them died instantly. Such a small things can lead to a catastrophic incident. This is just an example that I am trying to give you, that sometimes we think that a couple of photos was the big deal. In the springtime, we're going to do all the fixes on our gradings and special types of angle that we talked about in the morning by some of the presenters. Well, sometimes we are late, or sometimes it was not done properly. You missed the grading, or some other way, there was a drainage problem. The potholes developed over time, and even a small potholes like 5 centimeter, 6 centimeter, which is not much in terms of inches, 3 or 4 inches, it could cause fatality. So I'll finish with all the things that we see as an emerging trend, especially last 10 years, I would say. The first thing, obviously, Jolene will touch on, is the knowledge and skills and resource and regulatory checks. We've been talking all day about this thing. This first item is like mandatory and priority and highest priority. Well, other things I touched on already is the road condition, is the maintenance, level of service, the speed limits, the signage, and all other traffic information that we should convey to the drivers and road users. If it's not in the right place and it's customized for different types of conditions, we end up with common results, which is crashes. So I'll hand over to Jolene, and if you can take it from here.
Thank you, Dewan. So, good afternoon. I'm very aware of the time, and I'm standing between you and your break and winning a Tiffany bracelet. So definitely make sure you get over there and put your business card in the bowl. So, as Guy had said, I previously worked for a large single-tier municipality, primarily rural, over 5,000 lane kilometers of roadways. I handled the insurance, the claims, the litigation. So today I'm here speaking to you as a municipal risk manager, and building on what Dewan had said, looking at looking at how to put your municipality in a better position to defend against those claims, understanding that, you know, when accidents happen on low volume roads, they are very severe as far as fatalities and catastrophic injuries. So the Municipal Act states the municipality's responsibility to keep the highway in a state of repair that is reasonable. The Municipal Act also, that's in section 44.1, the Municipal Act also further states the defenses that are available to a municipality if the plaintiff establishes that their damages, their injuries was as a result of the condition of the road or a hazard on the roadway. So the municipality then is required to establish at least one of those defenses. Not all, but just one of those defenses. So one, it did not know or could not have reasonably expected to have known about the condition of the road. Two, it took reasonable steps to prevent the default from arising, or the minimum maintenance standards applied and those standards have been met. So generally, when a claim is presented, it's going to allege a number of things. It's going to say, you know, lack of repair, failure to inspect, inadequate signage, you name it. Plaintiffs' counsel are very creative when it comes to drafting a statement of defense. So, however, if a municipality cannot establish one of those defenses that are in the Municipal Act, it will be deemed liable. So, how do we defend municipality? Well, your defense is you need a solid evidence. So that is in part your documentation, accurate, consistent record keeping. Good documentation shows that the municipality fulfilled the duty of care in a reasonable manner, has policies and procedures in place that establish acceptable standards, and your employees are well trained and carried out their duties. Having good documentation can mean you could have a claim, a litigation completely dismissed because of the strength of your documentation that you're able to meet those defenses in the Municipal Act. It could mean reducing a settlement that is ultimately paid, which in turn then improves your loss history, your claims record, which makes you a better risk, which then ultimately influences your insurance renewals, your insurance premiums. So there is benefit at looking at and strengthening your documentation. How long should your records be kept? As long as possible. You know, we understand that we don't have endless storage for physical or electronic documents, but a minimum of 3 years. And I say a minimum of 3 years is because the Limitation Act in Ontario sets a basic limitation of 2 years. So if I was hurt today, I would have until October the 9th, 2026 to go to the courthouse and file a statement of claim against your municipality. I then have a further 6 months to actually serve it on your municipality. So that means extends it to 2.5 years. Therefore, that's why we say records definitely should be kept for a minimum of 3 years. That said, that completely goes out the window when we have a minor involved. So if you have a young driver, 16-year-old driver, you have kids in the back seat that are passengers, if they're injured in that accident, they have 2 years from 2 years after they turn 18 to file a statement of claim. Then a further 6 months to serve that on the municipality. So you need to make sure that your records retentions, your bylaws relating to records retention are definitely capture that the limitation period. All documentation should be clearly written, accurate, sufficient detail, and factual. No silly commentary. Avoid opinions. keep it to the specifics. Those municipal claims are long tail claims. So if you and your municipality are the ones that are going to be a witness at a trial, you want to make sure that you have accurate records. Your employees are trained to consistently fill out the records the same so that when you're going to examinations for discovery in 3, 4, 5 years down the road, that you can rely on and you can understand, you can interpret and explain to the other side, to your own defense counsel, what is being captured in that documentation. Trial can be 10 years down the road. So definitely you need to make sure that your record keeping is sufficient to explain. Basically, records tell the story. They tell the event, they tell what your maintenance are, everything that happened and surrounds that particular claim. Records are corporate documents. They're producible in the litigation and subject to FOI. And I remind you that the corporate documents, so if you have staff that are completing diaries, journal entries, those are corporate documents and they are subject to your retention policies. They don't go home with the employee at the end of the season, when they retire, whatever, when they leave their position. They are corporate documents, they stay with the municipality. Again, they need to be produced in the event of a claim, of a trial for litigation. And they're also subject to FOI. So you'll find sometimes that plaintiff's counsel, they may sidestep the litigation process and they may send an FOI request to your clerk's department and ask for everything and anything under the sun. So all your maintenance, your inspection records. You need to have a good communication with your clerk's department so that if that request comes in and it's specific to an accident, that those records that are being provided to opposing counsel, you're also giving the exact same unredacted records to your legal defense counsel. You want to make sure that your defense has the same, if not more, records. You don't want to be caught off guard at an examination for discovery when the opposing counsel has more information about your maintenance operations than your own defense counsel. Types of documentation. This is just in my experience when we have a road liability claim. This is generally what we were required to provide to our legal defense counsel. Other records could include anything from counsel reports, counsel decisions, statements from your employees, information on your capital projects, last known contact information for your current and former employees or anything. I would suggest that you make your own list. Make your own checklist of the records that you need to provide in a liability claim so that you're consistent every time that a claim does come through. So really, documentation, nothing's off the table. You want to make sure that you're periodically going through these to make sure that they're still meeting their intended purpose. That you want to make sure that if there's an MMS standard applicable, that the records that you have are showing compliance, and there's sufficient detail in there to show that you've met the standards of the MMS. You also want to make sure that levels of service policies, that once they're updated, you're still archiving the old version. Because say if you had a claim from 2018 and you're asked to find your levels of service or even your plow maps, your plow routes from 2018, you need to be able to go back into your records and be able to pull out that pertinent and relative information. Road needs study. If you're, in our case, engineering did the road needs study, obviously operations does the maintenance. If there's an update on your road needs study that changes the classifications of your roadway, so maybe formerly a class 4 road, because of the traffic count, it now bumps it up to a class 3, there needs to be communication between the departments, patrol records, patrol procedures, maintenance, that all needs to be updated as well. You don't want to be caught off guard where you continue to patrol a road at a class 4 when perhaps a year ago it was updated to a class 3. Again, you would be non-compliant with the MMS. Your electronic records, your GPS, I encourage you as well to do spot checks on those. We had a situation where we were trying to rely on our plow records and we pulled them out in our truck, although it was in the depot. The GPS records that we thought we had that we could rely on showed that the truck was in China. So, when you think you have electronic records and that's your your evidence, you need to make sure that you're putting an SOP or a procedure in place to do maybe a weekly check, just to make sure that it is gathering the information and it's accurate. It's showing when the plow's up, the plow's down, and what have you. My last slide. Oops. So the main things I think you need to is the training. We've talked about it throughout the day. Training, making sure that your staff are well trained. They have the knowledge, the skills, the resources to perform their duties, and they're empowered to look for things outside of just the regular patrol, their routine patrol, and their winter patrol. They're looking for hazards and bringing those forwards. Making sure that you're staying current on regulations and updates and the requirements, the Highway Traffic Act, the MMS, OTM, Dewan talked about the railway ones, the Railway Safety Act. Those are just to name a few. Knowing what's within your jurisdiction and what's outside, so what's an MTO responsibility, what's your neighboring municipalities, your contractors, being fully aware of that, not working in silos. For the interdepartment communication, talking about the road needs study and the FOI request, just making sure that you're working together. And especially too, if one report or study affects another, if you're doing a bridge inspection and there's hazards or maintenance obligations, making sure that that's getting to your operations department so that they can prioritize and put a plan in place. Precautionary investigations, I would suggest that if a serious accident does happen in your municipality, that staff are trained to do a precautionary investigation and go out and take pictures and collect that checklist of documentation that would be relevant and just set it aside. You're prepared, you have it, they've documented the road conditions, you could hire the adjuster to go out and do it on your behalf, but at least then you have that information so that if ultimately, which we could probably expect that a claim will happen, you're well prepared and have that documentation ready. And I would say also looking at your own claims history and becoming aware of what claims are happening in your municipality. And you can easily arrange that through your insurer to sit down and look at the claims, find out the status. Have they settled? Were they dismissed? What went well? What went wrong? What could be better? And that it's lessons learned, and it's going to help you to improve, become a better risk, and improve your loss history. And I would say technology, you can use your loss history to help support investment in technology, because if you can prevent one accident, if you can prevent one claim, if you can reduce a settlement or even support a denial, that's money saved that could be better invested into technology. So it's definitely something that you should think about if you're building a case study to help support sensors or electronic patrol records or additional telematics for your vehicles. But I would say lastly too, to rely on the expertise of your neighbors sitting beside you, your neighboring municipalities, your engineers, your experts, your defense counsel, your insurer. There's definitely information and that you can tap into and resources, and generally a lot of times it's free too. So, but anyway, I think claims will happen. You just need to be prepared and put yourself in the best possible position to defend against those. So, thank you.
Hello, oh, sorry, go
Oh,
ahead.
don't forget the cards for the bracelet.
Oh yeah, during break, drop your card off in the bowl and we'll make a draw tonight or later on this afternoon, right? Thank you, Jolene and Dewan here. There you go, thank you.
Thank you so much.
Any questions for them? I keep forgetting, but any questions for them? Oh, we got one right here.
One that's kind of come to my mind is you mentioned the uncontrolled intersections. In the Minnesota sign manual, it says on these low volume uncontrolled intersections, if you put up stop signs, your crash rate goes up. Have you seen any of that?
Yeah, so it's kind of opposite. If you have paved road and uncontrolled, is actually uncontrolled crash rate is higher, whereas it's almost opposite when it's gravel road or dirt road. The reason is very simple. You control in a different way, design and all like sightline. that doesn't need signage or anything. If your sight line, your sights, and the vegetation all are clear, the control is a very low volume. So keep in mind when we need a control, when there is a higher volume. If there is nothing, it's only 2 cars in 10 minutes, then it doesn't make sense to just put a stop sign. But it's always, if you missed all this kind of obstruction, visibility, and so on, yes, that's the critical part. So that's why it's slightly different dynamics, whether it's paved road or gravel or dirt roads.
Anyone else? All right, I think we're going to take a quick 10-minute break. Thank you, guys, gentlemen, gals. We're going to take a break. It's our last chance to talk to the exhibitors and to drop off grab their cards. And also, today's break is sponsored by Walker. So we'll be back in 15 minutes. Thank you.
just too much. My blood runs cold. Yeah, my memory has just been sold. My angel is the centerfold. Angel is the centerfold. My blood runs cold. My memory has just been sold. Oh yeah. Angel is the centerfold. It's okay, I understand. This ain't no never, never land. I hope that when this issue's gone, I'll see you when your clothes are on. We'll take your car, yes we will. We'll take your car and drive it. We'll take it to a motel room and take them all private. A part of me has just been ripped. The pages from my mind are stripped. Oh no, I can't deny it. Oh yeah, I guess I gotta buy it. My blood runs cold. My memory has just been sold. My angel is the centerfold. Angel is the centerfold. My blood runs cold. My memory has just been sold. My angel is the centerfold. A Monday warrior, mean, mean stride. Today's Tom Sawyer, mean, mean pride. Though his mind is not for him, don't put him down as arrogant. His reserve a quiet defense, writing out the day's events. The river
Okay, everyone, I think we'll come back and get started.
I can make the sunshine from pure desire.
Just like to take a minute, I would like to give a round of applause to all our exhibitors and our sponsors for making today possible. All right, should gravel roads be converted to asphalt or surface treated? That's the big question. We take a look at one municipality's approach and highlight the change from gravel to surface treated roads to asphalt roads. Karla Musso-Garcia is the manager of operations with the township of Oro-Medonte. She is a certified engineering technologist and a certified road supervisor with almost 2 decades of expertise in municipal operations. Thank you, Karla, for joining us. Oh, there she is.
So thank you, everyone. So I'm going to talk about managing low volume road network. Specifically, we've mentioned the switch that happened on our township roads from gravel to surface treatment to asphalt, and kind of the maintenance practice that we use now with the lessons learned from that transfer and how we're going to move forward. So the managing approach for our low volume roads. So a little bit about me so that you can understand the method to my madness on this. So I have over 20 years of municipal experience. I've worked at the City of Barrie as a project coordinator, working in the operations division, forestry divisions. I worked there doing their salt management plan and working in their operations division with the drainage stuff. In that time, I did a lot of the drainage monitoring and salt monitoring and the effects of our winter maintenance operation on our roads. Then I went to the town of New Tecumseh, and I was there for 8 years. I was the senior technologist there, overseeing roads and fleet drainage, and then became the manager of operations. And I'm currently at the township of Oro-Medonte as the manager of operations there, overseeing roads and fleet. Also, AOR's first vice president, and my background is environmental engineering technology. So the township of Oro-Medonte has various municipal services. We're a small municipality, very large in area, but a small municipality when it comes to the services we provide. We're sandwiched in between 2 large cities. So we provide the maintenance for our infrastructure, which includes the roads, winter maintenance, bridges and culverts, sidewalks, which is a bustling 6 kilometers throughout the whole township, and traffic systems. Then we have the drainage, which includes our storm sewer systems, the municipal drains, easements, and ditches, roadside ditches in rural areas. We look after the vegetation forestry, which is a little bit different than what I had to deal with in forestry for Barrie and in New Tech. Those two tended to be roadside trees that were planted. In Oro-Medonte, we're dealing with a lot of natural trees growing wild on the roadside. We're also dealing with noxious weeds, invasive species, and the movement of that throughout the township. We have a sister department with environmental services that oversees the water, wastewater, communal tiles, and streetlights. As well as public spaces and services with our parks division that oversee the parks, recreations, our cemeteries, facilities like the arena, and special events. We also work really hand in hand our fire safety department, emergency services department. Our fire crew are volunteer firefighters, so our operations division really works hand in hand with them for emergency road closures, emergency management response for weather events, and severe weather response as well. So the community profile for Oro-Medonte. We have 23,000 population, but it's only approximately 8,636 households. Our land area, however, is 61,000 hectares, and we're bordered by City of Barrie, City of Orillia, Township of Springwater, Township of Severn, and Township of Tay. So the road surface profile, where we spoke in the introduction about the surface types that we have. In 2009, we had 175 kilometers of gravel road, 96 kilometers of surface treated, and 290 kilometers of asphalt with just under a kilometer of concrete. From 2009 to 2019, there was a change, and you can see that our gravel roads went down to 18 kilometers. You can imagine that that change did not come with a lot of the changes that a lot of the presenters spoke about ahead of this presentation. So a lot of these roads served a rural purpose. They were cottage roads, they were farming roads, they have a lot of organics underneath. There's stumps that pop out of the ground. We have corduroy road, we have a lot of these locations didn't have a great base. That change moved over to surface treated, and we have a big spike in asphalt as well at 466 kilometers. So we had a bit of growth as well from the total number of kilometers from 562 to 608 kilometers. From 2019 to 2024, however, you'll see that we have a change in reduction of gravel again, 3 kilometers. And then we have a reduction from our surface treated from 123 kilometers to 61 kilometers, and asphalt from 466 to 536. These are all centerline kilometers, so the amount of asphalt is pretty significant. So when looking at it from a maintenance perspective, a lot of the minimum maintenance standard items that are discussed in maintenance practices, and you're looking at it from a traffic point of view, our roads in 2024, so today, 84% of them are low volume roads, that their annual average daily traffic is below 1,000 vehicles per day. Even with the growth that we have projected for the area, we are still at an estimate of 77%. So from the MMS profile, if we were strictly to look at the minimum maintenance standard component from a road network perspective, we have a very low classification of road network. The 2019 PCI index showed that we have a pretty good road surface pavement condition index. And with all of the asset management literature and everything that we have, that the deterioration of our road condition, if we're not maintaining it and it's not built to a proper standard, is going to continue going down. Any of the engineering principles that we would apply to them are subject to the base that's there and subject to the conditions of the roadway. Our asset management plan identified that we operate and maintain the core infrastructure with a historical cost of $95.3 million and an estimated replacement cost of $436 million, which the majority of it is $364 million, or 84%. That's the township's municipal road network. So our core infrastructure is considered to be good condition on average, but there's specific components that are approaching the end of their useful life. However, the township's annual funding for maintenance and capital replacement core infrastructure is not sufficient to meet the requirement within the township's forecasted, requiring between $67.6 million to $122 million for life cycle maintenance activities for those core infrastructures. We have the increased traffic volumes that may require the township to revise the approach to the replacement of roads. And while the township has not identified the needs for additional lanes to accommodate the anticipated growth, the traffic volumes may require different surface treatments. So with this statement, we're falling behind on a daily basis. The road condition is going to continue to deteriorate. We need surfaces that are going to be able to last for a longer period of time. If we were to raise taxes in Oro-Medonte by 1%, that gets us $175,000. In order to be able to fund that asset replacement is not going to be reasonable from a tax perspective. We're going to have to figure out a way to eat the elephant. With our asset management plan, it identified the useful life for all the different surfaces that we have within the township. And it identified that the surface treated roads would be a useful life of 12 years and our asphalt would be at 15. Again, that's taking into account that the road condition for the base and subbase of the road, the ditches, the shoulders, are all in some sort of engineered process, which they are not. So the projection of useful life deteriorates fairly quickly going forward. The resurfacing cost that was identified in the asset management plan identified that on a per kilometer basis, surface treatment would be $502,683, and then for asphalt it was $608,157. So on a resurfacing cost per kilometer per year of useful life, the surface treatment cost would be a little bit higher than the asphalt. So in the decision for moving forward on the surface requirements, we're able to make that, that decision that the asphalt would be able to give us a little bit more service life. So again, when we're talking about the maintenance principles from a road network perspective, our municipality is looking after the roads, but really the operation division that I look after, when we're talking about the services that we provide, we're providing services to a community. So we're trying to look at it from beyond the maintenance of the road condition, the asphalt condition in the ditch, and it goes beyond that. So this is an objective that we have in our winter maintenance plan and training that we do with our staff, that when you're thinking of winter maintenance, it isn't just to remove the hazard of the icy condition or remove the snow. The intent isn't to just meet the minimum maintenance standards. So the routing that is decided, the locations where things are going to be placed as far as snow, the decisions that get set for setbacks and routing have the objectives to reduce the hazards, to comply with legislation, to reduce the economic loss to the community. So if people can't move throughout the community, they can't make money, they can't bring money to the community. Our municipality has ski hills, so usually when it's snowing and it's bad weather, that's when we get people into our community traveling these low volume roads. We want to facilitate the movement for emergency vehicles during winter weather conditions. We want to promote a consistent level of service throughout the municipality. We have a very broad range of property values throughout our municipality with some lakefront mansions and cottages and ski chalets. We want to develop and implement winter maintenance procedures that set measurable objectives so that we're able to monitor our salt management and compliance with minimum maintenance standards. And we want to reduce the impact on the environment. So Oro-Medonte has a very wide set environmental protections throughout it. It has a lot of natural heritage features throughout it. It has lots of rolling hills, lots of water that I'll show you in later slides. So we want to reduce the impact in the decisions that we make. We want to communicate the training to staff and having an understanding of what the services that they're providing for the community, not to the asphalt. They'll learn those technical things as well, but we want to train them and communicate that training to the service that they're providing, which is a service to the community and what that means. And we want to implement alternate winter maintenance practices, and we've implemented some alternative drainage practices as well. So to switch to kind of risk management 101, if you think about it from a health and safety perspective, if there's a hazard on a piece of equipment and you need to eliminate that hazard, from a health and safety perspective, you want to eliminate the hazard entirely. You want to substitute the hazardous material or process. You have engineering controls, so you either isolate the people from the hazard through equipment design. You have administrative controls where you change the way people work, including training and scheduling. You provide personal protective equipment to those people to use equipment and protect themselves from the hazard. And if something does go wrong, you have first aid and plans to respond when controls fail. So using that concept for our road maintenance and the services that we provide, We wanted to find out what damages the road surface. We're not going to be able to provide the road service maintenance to keep it at a high PCI for a long period of time. I work with Justin Metras, who's sitting over here. He's the manager of infrastructure capital. And as much as he paves roads and gets them to a higher standard and deals with the deficient road issues, our PCI index on a lot of other roads are falling into worse condition. So looking at it again from a risk management perspective and looking at it for what's the hazard. If it's a person working at a piece of equipment, we're looking at a hazard from a roadway and what's the hazard that's causing the roadway to have an issue. So you've heard it through all the presentations throughout today, drainage, drainage, drainage. The hazard to roadways and the hazard to the natural landscape throughout the area is water. So floods and flood water devastate infrastructure, and they're causing a ton of structural damage from a storm event, from environmental events, and in the US, there's been over $1 trillion in damage since 1980. In 2019, the storms and tornadoes from those weather events cost $1.2 billion in US infrastructure damage and $175 million in emergency response. So when something fails, we have to respond. And as municipal public works workers, we're the ones usually going to go deal with the road closures and the flooding issues and trying to navigate what has happened and what we need to fix. Then we need to respond and deal with those specific issues that wouldn't have necessarily been planned out at that time. So either we're using the money at a preliminary standpoint or in a reactive standpoint. So in Ontario, the floods that were in 2019, there was a lot of vulnerabilities that happened through that time. Oro-Medonte was no exception. We had a ton of flooding that happened through our Lakeshore Road section and through the Simcoe County, Lake Simcoe watershed. And there was a lot of financial burden on us on having to upgrade a lot of drainage components that we weren't really looking at before. The extreme rainfall and climate change could cost Ontario municipalities an extra $700 million annually, and that comes from the Financial Accountability Office. So stormwater damage in Ontario. So when we're looking at the risk, we're trying to focus on the risk and what is the thing that actually damages the road, and we're looking at water. It's going to be the stormwater that travels through our systems. So in the management strategy that I use is we look at the precipitation rates, the climate, what it's changing, and what is projected. So in Oro-Medonte and Simcoe County area, from 1976 to 2005, the average annual precipitation for the year was 884 millimeters. It's risen to 941 between 2021 to 2050. We are reaching those numbers already on an annual basis within Oro-Medonte, and it's projected that in 2051, so for our long-term planning, long-term investment, it's going to rise again to 970 millimeters per year. So in July 2024, the flash floods in Toronto and Southern Ontario caused over $940 million in insured damage, according to the Insurance Bureau of Canada. So again, looking at it from the lens, not necessarily just from a township infrastructure, but from a community standpoint, if our drainage systems fail, that has another financial impact in the community and the residents that live within the area. So the necessity for drainage to function is beyond the roadway. It's beyond the area that it's traveling in and beyond the traffic that's on that roadway. So going back to this risk management hierarchy controls, thinking it from kind of a health and safety perspective and what that risk is, but changing it into risk management for a roadway. If the road is our patient, we want to eliminate the water. So we want to prevent the water from getting to the road and surface and design the roads to prevent water accumulation. We've put the roads into a natural landscape, so the roads are there. We can't eliminate the water from traveling through it, but we can reduce the amount and we can make changes from an engineering perspective as well. We can make substitutions and use surface materials that are less prone to water damage and provide a longer life cycle, which is part of where we've done the switch from the surface treatment to asphalt for some of our roadways. That doesn't necessarily mean that it's going to be the consistent practice on every single road that comes forward. It's going to be evaluated on a road-by-road basis. But at this point in time, when we're trying to eat the elephant, those extra 3 years from that asphalt perspective is going to give us a longer time period. We're going to look at engineering controls to isolate the hazard and construct outlets and culverts to provide the adequate flows to redirect the water and reduce the contact time with the road. And we're going to do administrative controls, change how the roads and drainage is maintained and evaluated. We're going to do regular inspections and proactive repairs and seasonal maintenance schedules and shoulder maintenance. That administrative control is something that we've already implemented, not to this level of detail, as simple as it sounds, but we wanted to change the mindset from a service delivery perspective at the equipment operator level, and I'll talk about that in a minute. From a preventative maintenance perspective, kind of the PPE, Justin's group does crack sealing, microsurfacing. We've done some slurry seals in areas that we want to prevent the water. So there's already been cracks on the road. There's already issues that have happened on the road. So we're doing some preventative maintenance PPE and doing some first aid to it. A first aid component would be patching the potholes, doing additional crack sealing, clearing plugged culverts, etc. So why we changed the thought on our maintenance from a roadway instead of just looking at it at a surface component. The climate trends in Ontario, the chart on the bottom shows that we have the rain precipitation rate increasing. Our drainage profile, we mentioned the road information, so we have 601, that's a center line road kilometers, so we're about 1,200 kilometers of ditch. If we were doing the ditching in our roadways at the rate that we were doing it before, it would have taken us 300 years to get through the whole municipality to be able to provide proper, adequate ditching throughout the municipality. Only 3.3 kilometers of storm sewer. So what does that mean for the road maintenance practices in Oro-Medonte? Is we can look at it from a traffic volume perspective, minimum maintenance standards perspective to prioritize our maintenance. But that road travel condition isn't necessarily what's causing the issue. We're looking at it from a catchment area drainage review. So we're looking at drain condition evaluations based on an upstream effect. If we're noticing a deficiency on a certain roadway, we want to find out what's causing the water to stay in that location and not look at it necessarily in isolation for that area. And we're looking at it from a full catchment area review. And we're also looking at it from those sub-catchment areas, what the outlet capacity flows are so that that's adequately sized for that area. So our drainage profile here, we have 3 watersheds that all outlet to Lake Huron, and the average rainfall for last year was 780 mils, and we have 265 centimeters of snow. So we have Severn Sound watershed, Nottawasaga Valley watershed, and Lake Simcoe watershed. This is the map that we utilize for looking at our road network and the maintenance that we need to do. So we have all those sub-local creek watersheds in those areas. When we overlay that with our request for service, patrol records, surface deficiencies from a roadway, we're able to see what the waterways are that water's supposed to travel to. So we are able to look at it from the downstream approach, make sure that at the outlet point of the water, all the way back to those deficiencies, we don't have any deficiencies and are able to reprioritize. So this is just all the sub-watersheds that we have for the area. And we also have to look at where development has gone in. The water is going to move differently than it had before. You see I'm running out of time, so I'm just going to move a little quicker here. We have, prior to development, we used to have about like 10% runoff of water and 40% evapotranspiration and 50% infiltration. As development goes in, the infiltration rate goes down to 15%, and we're increasing our runoff to 55%. The evapotranspiration is dependent on the amount of vegetation that you have throughout the municipality. So keeping that in mind, the importance of the drainage and the catchment area is very important. It's been talked about at length throughout the presentations today, but water moves material. So the fines, it moves things, it damages stuff. So we've changed our operations to have drainage training, and we've created an internal drainage training for our equipment operators that are able to understand the catchment area zones, the drainage zones, the environmental regulations associated to it, the type of deficiencies that are caused in asphalt surface from a drainage perspective, and what to look for on a downstream standpoint, because the actual deficiency from a drainage perspective may not actually even be at the road location where the deficiency is happening. So we have a consultant that will do, when we identify an issue, we'll get them to do some data modeling and identify at the very outlet point for that catchment area what that sizing is supposed to be, and we start at the outlet point to make sure that that is adequately sized for the whole catchment zone, and then we can start and continue maintenance going upstream of that drainage zone. So some of our training or drainage investments that we've done internally with staff have been little dead-end roads that go out to the lake. From a traffic perspective, they're insignificant. From a PCI level, they're insignificant. There's residents that live on the road, there's access to it, but the flow rate and the impact of the drainage component on these roadways is incredible, because their zone that this outlet captures an incredible amount of asphalt upstream. So we focused on getting these outlet points completely updated and fully engineered. Once those were fully engineered, we were able to start moving upstream, and we were seeing improvements in the asphalt condition as the water was able to move out. So that's the administrative controls that I mentioned that we have done with staff. With the drainage maintenance, so this is, we are tracking all of our requests for service and seeing what residents are calling about and what they're concerned about. So this is the drainage maintenance calls that we've gotten this past year in 2023, and then the asphalt condition calls that we've received. So if I flip back and forth, you can see that there's a bit of a parallel associated to those, and we're able to use the right-of-way maintenance calls to be able to determine the next locations that we need to look at from a drainage perspective. Our calls for service from these residents. So since we've switched and changed over to our maintenance practice to look at the drainage, because we're now going to fix the issue that's causing the concern, we've had a reduction in drainage work orders from residents by 36%, and overall maintenance calls by 11% for that first year. And we've been able to then have staff not have reactive maintenance calls to all of those resident concerns and change what they're spending their time on a different basis. And it also changed the staff knowledge and skills perspective, that they are learning about stormwater, knowing how to understand stormwater, that when we have those stormwater events from an emergency perspective, they're able to handle them on a day-to-day basis. The calls for service this past year, since we've implemented this, we've had a 52% call reduction from residents in regards to right-of-way drainage calls, to 32% in road surface maintenance calls. Right-of-way vegetation has decreased by 23%, which we actually saw, there's a spike, but it's still a reduction because of the ash trees. Traffic signs have reduced because we've now been able to start focusing on traffic signs. If people aren't jumping every time a resident calls and we're dealing with the problem at the outlet, we're able to deal with our traffic signs on a more consistent basis. And importantly, our winter maintenance calls reduced because our snow is water and it melts and it moves through those drainage systems. So our winter maintenance calls actually reduced by 61% and 58% overall resident complaints. I'm just going to skip over this part, just vegetation control we're able to move through. But this is an example of Warminster, one of our snowstorms that we had in 2022. All of this is water. So sometimes we may look at winter operations as an isolated system that it's dealing with the roadway. all of that snow is going to melt. It's going to turn into water. It has to outlet and it has to move through the area. And in wintertime, it's not going to get the infiltration that it needs to. So you need to look at it from an outlet point of view of where it's going to go. And just some other fun pictures from that same storm. So moving forward from an asset management perspective, our updated PCI index, since we started switching over to this style of maintenance, and Justin's group has been able to do some really aggressive paving switch over as well. Our PCI index has improved, and you can see that we are now at 61.21% in excellent condition. By our numbers, Justin's team was able to pave 51 kilometers of road over the 2 years. And it has a bunch of other information in there. And my team was able to do 130 catch basin cleanings, 6 kilometers of ditching in that year. The previous year, we actually had done 17, but we also replaced 126 culverts and road crossing culverts that year as well because of our focused efforts. So, any questions associated to that?
All right, thank you, Karla. Just a reminder, we're going to have some draws, 3 draws for $100 gift certificates after our next, our final presentation of the day. We are heading into our final session of the day. Our keynotes will be up here answering your low volume roads questions. We have some questions already sent via email from Good Roads membership, which will start off and have some submitted via our registration desk. If you'd like to ask an expert a question, please raise your hand and we will bring you over a microphone. Please state your name, municipality, and organization to ask your question. Welcome back to the stage for the final time, David Anderson, Dr. Jolene, and Brian Keierleber, and monitoring this session would be Antoine Boucher. Is there another mic?
I don't really need one.
Okay, so this is our last panel, keynote panel. So we have Dave, and then it's Halil and Brian. So thanks. So a few questions. We're going to just start right away. We call this one the road less traveled. So for municipalities that are starting to consider converting the roads that they have that would be in distressed, roads that are paved, and they're starting to default back into considering to turn into unpaved roads. So going backward, in a sense. So from asphalt to gravel and turning those roads from asphalt to gravel. What would be some advice and recommendations that you would have thinking of the municipalities that are considering doing that move?
There's been some studies done in Iowa because there's some of the counties in Iowa have been forced to do a significant quantity of this. And J.D. King's one of the county engineers down there in Page County. He put together a full presentation on how to do it. And so there's, I'm going to use the term a manual, but there's some guidelines there. But the big thing is he basically said, this is how many miles of road we can afford at the present time, at the present funding. And so that means these roads will need to be converted back to aggregate when their deterioration gets to a certain level, and they've got that defined too. And I even think back to visiting with my brother. The roads I grew up on in South Dakota were surfaced in the 1960s and converted back to rock roads in today's world because the entities couldn't afford to maintain them. But there are some guidelines out there, and it was Page County and J.D. King, and I could try and get copies of his presentation if somebody wanted to contact me on that.
Halil, you wanted to add, or Dave? Contrary to what Karla's been doing, in a sense.
Yeah, I think if you get to the point where you want to convert it to gravel, there's been a couple of things going on, and it's number one, you were underfunded forever. That's why the road's in that condition. And now you're converting it from a surface type that should be lesser to maintain, or that's most of the studies that I've looked at, should be lesser cost to maintain that hard surface road. Now you're converting it, you don't have money in the first place, and now you're converting it to a road that should be costing you more money to maintain because of calcium, because of extra, aggregate and material and things like that. So there was a methodology, if you will, or a practice back when I used to manage the road system for the region of Halton and Norfolk, and we had a budget called maintenance paving. So if we had a road that we knew we weren't going to reconstruct in that 5 or 10 year horizon, instead of doing a detailed let's repair the base, let's put a lift on, is just put a maintenance pave 50 mils of asphalt on top, knowing that it's not going to last the 15 years or whatever, it's going to last 5 to 10 years. But now I've eliminated or reduced greatly the amount of maintenance that I'm doing on that road. And, if it stays a hard top, then I got a lot less materials that are being used over that time period as well. So there's some considerations. And again, going back to a slide that I had there, it has to do with, like, if you're making that evaluation, make sure you've got accurate costs. Because all too often, people say, oh yeah, we can do that for cheaper than a contractor, as an example. I know there's lots of contractors here, and to tell you the truth, I've been through that analysis a lot of times, and I don't think we as municipalities can do it cheaper than a contractor, because we pay the same to our staff, we pay the same for vehicles, and we probably work less hours per day. So you start to analyze those things, maybe that's a faulty analysis, converting a hardtop back to gravel.
They're kind of forced to, but what we really have to look at is the traffic volume levels too. And so many of these roads are not, many of them are in the 10 to 25 vehicles per day. On a paved road, I better more like 100, 150 vehicles a day that they're converting back to the aggregate basis. And the other side of it is, I look at my winter snow maintenance, and one blade operator will take care of about 70 miles of road, and each one of my snowplow trucks on the paved roads takes care of about 20 miles a day. It's a level of service issue is really what's coming into play there. I don't expect to get across all my rock roads with a motor grader that 70 miles in one day. They're going to take them 2 to 3 days to cover their entire route. The people that live on there know that. If we stop and think of the farmers, most of them have equipment bigger than what the county has to get out and get the snow open to get to the hog confinement centers and such. So they're doing that level right there just to survive. It's kind of what it amounts to.
Dr. Halil?
Yeah. So what I can add is that, again, as other colleagues also mentioned, the main reason that this is happening is economics. We just don't have the funds, to provide to keep those paved roads in good conditions. But I remember I was actually interviewing a county engineer colleague for one of our bituminous surface treatment techniques, autoseal. Are there any autoseal applications in Canada that anyone is aware of? Anyways, maybe that can be another actually future, presentation topic. So then I asked them, how many times do you go and maintain that road? We had these like standard questions, and I was just jumping into the next one. His answer was 6 times a week. I was stunned, and I'm like, you have to keep a motor grader in that location like 6 times a week. Perhaps Sundays is, they say the religious service day. I mean, that's a lot of maintenance, by the way. So that road was actually costing them more than a paved road. So we have to get these, the costs, in mind as we make these decisions. Other thing that I want to mention is, with my, the geotechnical engineering background, there are also some initiatives called inverted payments. And I'm in favor of that. Inverted payments means you still get the fundamentals right, that you have good drainage, and then you provide a very strong payment foundation. So you invest heavily in your subgrade and base layers, and then you minimize the top surface that you're going to be adding to keep that road in good condition for many decades to come. So I'm heavily in favor of inverted payment systems, but then you have to do your homework, get your payment foundation, in a really beefed up, manner. So there are a lot of studies going on in that, in that initiative, inverted payment systems, which is in relation to the discussion that we're having. So,
all good practices. So, and one thing that Good Roads has been investigating a bit is the study on all the stockpiles of recycling reclaimed asphalt, the big piles of asphalt that we see along certain highways. And so the quantity has been somewhat evaluated to be about 6.7 million tons that is sitting in piles. And when we think of low volume roads and gravel roads, would I be able to get a little bit of your opinion or your intake of like how could we use them successfully, or I've maybe use of that material successfully for gravel roads, and if you would see any benefits of using some of those resources of materials?
It's wonderful material if you can get your hands on it. And you probably, most of the time when I get millings, there's chunks in there and you got to crush it down. But if you can put it on, you'll just about turn a rock road into a paved road. And it works beautiful. The reality is in Iowa, a lot of it gets recycled back in, a percentage back in with the new hot mix. And so there's a significant value to the oil in that wrap.
Yeah, that's we see that percentage being discussed, of course. Any other intakes on the use of recycling aggregate into gravel roads, low volume roads?
Well, we have to recycle because we really literally ran out of the first use virgin materials, and anything that we can do to increase recycling, reuse of materials, that's the only way we can be more sustainable in today's the world. So we can utilize them in many different ways. They are still subject to the same standards and specifications. Just because they are recycled, we're not lowering the bar. And like I mentioned to you about autoseal, we can actually take that material, use as aggregates in this case, and use it for a bituminous surface treatment technique, which still you have to add additional binder to hold those, the materials together. There have been also a lot of studies that, like we have concrete, which is very rigid, and then, we can actually utilize asphalt and still add, Portland cement concrete. Then that provides you a little bit more flexible, the material. So there are advantages of that kind. But as Brian mentioned, in worst case scenario, we can utilize them as, aggregates in that case. And actually, contractors call it black gold because they get paid when they reuse that material for like in-place recycling, as if like they just got it as like the new material from the, the asphalt plant. So, and all of those initiatives have been done to promote, recycling and sustainability. So, there are a lot of uses of them, and we have to build test sections and do research, see, what dosages and under what circumstances we can actually get the best performance of materials of that kind. But I highly promote, again, reuse and recycling.
Dave, I don't know if you have some experience to share with.
Yeah, well, I'm a big believer in recycling, and one of the products we talked about towards the end of my presentation was using 100% wrap to create additional structure. Now, the problem I see with wrap is that wrap comes off a hot mix asphalt road. Hot mix asphalt requires a higher quality aggregate than we use on gravel roads. So then we're taking a higher quality aggregate and we're using it in an area where it's not really required. So it might not be the best use of the wrap. I think there's other maybe uses for that, and there have been some issues with placing a wrap on the surface and getting adequate compaction. If it's just straight wrap on the surface, getting compaction may not be achieved, and then you end up with it potholing more quickly, much more quickly in a lot of cases than a a traditional pavement or a surface treatment. So those are the kind of issues I kind of want to think about.
And I think you also see some blends. I hear a lot of 70-30% mix or a 50-50 mix.
Yeah, in our OPS, we provide for up to 30% wrap in a granular A material. So you could use it that way, but the reason it's 30% is to stop it from sticking to itself as you're placing it down.
Not to return the asphalt pavement from the old wrap. Today we talked a little bit about the plasticity. We talked about if I refer back to again in Ontario, we've got the Ontario Provincial Standards specifications. There's one in particular when I talk about plasticity index, OPSS Muni 1010. Which we referred from our colleague from California that was talking about that slide when material specifications for aggregates, base, sub-base, select subgrade, backfill material specify a plasticity index value of 0. So when we think of that and some of the discussion we've heard, the question here is more like how important is the plasticity index to the performance of granular surface materials. Would you be able to talk about that a little bit or share some knowledge on your input on plasticity?
I tried using steel slag one time. That has no PI, washboards immediately. Why was I trying it? Because it was in an Amish community and the steel wheels on the buggies just crushed down my limestone aggregates within weeks.
So the highly plastic soils significantly impact the performance of, the granular roads or granular materials and all that. As soon as you pass about like 5% of them in the, mix, the gradation, they just start, governing the overall behavior of, even if you have a lot of granular materials and all that in it, but as soon as you pass that 5-6% threshold, they have huge impact in the, the behavior. So we're trying to stay away from actually utilizing those kinds of, the materials, but there are, the certain conditions that, that you try to limit it as much as you can, but, the availability of the local materials and all that, you just can't, escape from that. So it will have adverse, the impact. That's why we have to do a lot of optimization studies and, the limit their use to the best of our, the ability. So, and whenever we can, we try not to use highly plastic materials in, the road foundation systems.
Yeah, I'd agree with trying to stay away from plasticity in the granular materials, although there are some states that do specify the small amounts like a 3 or 5% plasticity because it helps it bind together and they get a better performance. I think the issue, performance from a gravel road, but I think the issue for us would be controlling it. Like if you start to introduce it, like how do you keep it consistent at that low level? And I think that's the hazard. And then, okay, if we're going to do that for gravel roads, what happens to the granular A that we're using for traditional road construction? And is that going to work its way into that too and cause a performance issue over time?
And I think like as it may hold moisture, and then as it does, then ultimately through the different weather environment and seasonal changes, again, perhaps that's another challenge. Brian, in your presentation when you were talking about all those bridges and the nice pictures you shared, I couldn't help but notice some of those tractors getting bigger and bigger. And when we think of the impact of heavier loads through agricultural equipment, the increase in traffic and so forth, we think of also the low volume roads. And the challenges on what do we do to improve the strength of those secondary low volume road in a sense. So from what you've experienced or seen, would you have any input on what could we do to improve?
We're playing around with a whole lot of things, and one of the big things that we're playing around with Dr. Jolene here is taking the waste plastic stream and turn it into a fabric that we can strengthen the road bases with, much like Tensar's geotextiles. And when we started working on this about 3-4 years ago, Tensar, Soilmax, none of these companies were making any of the fabrics with geotextiles. And now Tensar has one that's 100% made from recycled plastics. I've had pretty good luck with some of my roads using fabrics, like a 10-ounce non-woven geotextile. And real pleased with some of the results we're getting that way. The issue is the size of my system and the cost per mile becomes a real challenge. And so we played around with chemical stabilizations too, and we just did a whole bunch of that within the past month. And Dr. Jolene's, I like to build things out in the field and come up with strange ideas. He's the one that's got to study and tell me what's working.
So it's a toolbox.
It's a toolbox, is absolutely right. 2019, I had horrendous frost boils. And remember, I've got these hog confinement centers out there. They got to get grain in and out daily. They got to get pigs in and out regularly. And if you got huge frost boils, what they do is they take the semis and they drag them in and out with the huge four-wheel drive tractors. Now that road becomes impassable to the local residents.
Right.
And so, yeah, there was a lot of grinding of teeth and wailing and petitions to fire the engineer. So since 2016, we've been working on different ways of doing it. I've worked with a Jay Lemansky from Especially Products Group, which they work up in Canada a bunch, and we put down some of that material. We've done Portland cement stabilizations. We've done a claycrete stabilization. There's a material that came out of North Dakota called Team Base One product. We've done some of that. Polymers, I put down some polymers in 2019. My crews go, Brian, that smells like Elmer's glue. And it worked beautiful, but the surface didn't last. Now, one of the things that's going on in Iowa, and there was a professor at Iowa State that developed a vibratory roller that can go down the roads and get the shear strength of your road base. And so they've run virtually all the miles of my rock roads with this vibratory roller. Now I can come back and try and start identifying the soft spots. So I'm not going out there and trying to treat mile after mile. I'll treat the weak points in those soils. Yeah, I've played around with a lot of different things, and I can't stand the one that I did in 2019. One of the big things when you're dealing with geotextiles, and I like non-woven because of the separations, my silts will really move, so geogrids aren't quite as good in that environment. And so what I did, one of the problems is if the soils break down, you'll get into your fabric with the motor graders.
Right.
So I said, well, bury it down about a foot. So I said, just peel the top off, throw it in the road ditch, and then pull it back up. And they said, can we clean the ditches at the same time? And I said, sure. Now this road's carrying about 200 vehicles a day. It's one of those that might possibly save me money if I paved it. But I couldn't dare pave it unless I strengthened my soils, because this frost heaving issue is a real challenge in this one. The name of it's Frost Boulevard.
Now,
At any rate,
Dave, I was going to cut you a little bit maybe with the, I was thinking for the Ontario standpoint, I'm not sure what's your thought on maybe using like maple syrup for a good foundation?
I guess we're looking for glues.
Yes.
But yeah, we have similar problems here in Ontario because the Highway Traffic Act exempts a lot of the farm traffic. So, and as you saw from the pictures in Brian's presentation, we have similar things going on. So I think the idea, people will have stuck in their head, oh, it's a low volume road. Yeah, but, and the equation is like a sports car is a 0.0002 easels and one of the transport trucks like 2.4 or 5 or whatever easels. So we have a huge difference in load on the road. So when we go to do something on that road, doing a little bit of a touch-up might be just wasting money. So I think we got to do as Brian suggested there, is if there's problem spots on that road, then identify the problem spots and fix those. if you're faced with that kind of situation. So you're optimizing available funding, but then identifying just those areas where you actually need the structure added.
Yeah, we touched on quite a few of those techniques as well, so it's good. The next question, I'm thinking it's close to me because again, I'm from the North Bay area and so forth. Like we deal a lot with frost heaves. Obviously, that is a challenge. We talked about half loads, restrictions, and so forth, and then frost heaves is definitely something that we deal with all the time. So, from your opinion, how would you best mitigate this case of frost heave when you see one?
First of all, you're really best if you understand what the frost heaves are. And I tried to go through some of the math, so I was thinking about, but your soils may freeze down as deep as 2 meters.
We're further north, absolutely.
Yep. And so you're maybe 10% moisture in there.
Easy.
How do you get 25, 30 centimeters of frost heave? Well, the science behind this is that the soils will set up capillary action. They'll start freezing into a frost lens. And that zone of pure water just keeps growing and growing and growing. And then in the springtime, if we thaw slow, the Earth's a big heat source. We'll thaw from the bottom and that moisture can get away. If we thaw from the fast, like we did in 2019, we'll thaw that zone of pure water underneath our road surface and have frozen ground underneath that so the water can't escape. And then you start driving on that and you'll actually get geysers shooting the Gookumpucky, I think is what they called it, up, but it's chocolate pudding. And so you got a real challenge there trying to keep any type of a road surface. Historically, what's been done in Iowa is you try and bridge over it, and that's where we're trying that with the fabrics and such. They are trying some other research in Iowa, but my real concerns is it depends on how deep things go. One of the things that they've done is dig post holes basically, and in some counties in the middle of your road, and then fill that full of a permeable aggregate, or others have actually put salts in there, and I'm not sure how any of that's working. I think the aggregates are working. I'm real curious on the salts.
I know we see a lot of the corduroy roads that resurface over time here, and then those are interesting. When I don't know if it's archaeological or not, but any other mitigation that you would say from the Ontario perspective, or?
No, I think Brian's description of how a frost lens is caused is how I would present it as well. So, yeah, how do you mitigate it? Well, I think you got to deal with drainage is always a big issue, right? So if we can stop that action happening because the base is freer draining, that's certainly going to mitigate that to some extent. And then when you do see frost action occurring on a road, as I suggested, I think you got to limit the traffic action, like the heavy trucks, commence your half loads when you're seeing problems rather than waiting for, well, it's not March 1st. Yeah. And in this case, this year, we had a very soft winter in southern Ontario last year, so it's like, when was there really a spring breakup or a spring thaw? So I think we got to, keep our eye on what is actually happening. And there are tools. I think Good Roads has a tool, or they were looking at being able to use the RWIS stations to tell you when half loads should be introduced in your area. So there are tools out there for municipalities to invoke half loads when it's required.
To do a better prediction.
Yeah.
No, that's good.
So what I can add is that, we're talking about good roads here. Good roads are engineered roads. So we have to engineer our roads. Like, we can actually use, the most susceptible soils for Iceland's formations are silty soils. Their particle size are just like ideal for that. So if we can eliminate those kinds of soils, or they are unbound soils, which means there is no bonding agent. The team talked about cement treatment and other, the stabilizing agents. If we can treat them, we reduce their susceptibility to those kinds of actions very significantly. And we can take advantage of all these wonderful tools, products at our use. For example, geotextiles. They can act actually as a separation layer, drainage layer for stabilizing action. So we can hit many birds with one stone by utilizing those kinds of, the products. And in the long run, yes, we have to invest, initially to use those kinds of products. But if you do a life cycle cost analysis, or better, a life cycle benefit cost analysis, the benefits are definitely outweigh the costs, and then they are actually more economical solutions in the long term. So we just have to keep these, the fundamentals in mind.
Well, thank you for that. So I'm, again, being conscientious of the time. I may not go over all of the questions we have, but I'll cover one or two more. From your perspective, some of the key factors, takeaways, as we're thinking of considering an upgrading of an unpaved low-volume road to either a surface-treated or paved surface. So what would be some of the those key factors that we should consider before implementing in the next steps of transforming those gravel roads to paved or surface-treated?
As the experts have been telling us, drainage, 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 and then you better get some strength in that road base too if you're going to put any type of a surface on it. And that's where you can get an awful lot of money put into it before you ever start putting the surface in.
Yes, and I got the drainage from Dr. John Emery, so it's not me that came up with that. It's been around for quite a while, yeah. So, yeah, you have to have drainage, and certainly in Ontario, we have standards for widths, minimum tolerable standards for widths, minimum tolerable standards for shoulder widths. So we have to make sure we have that, because there were one presentation talked about litigation and those kind of things. So when we touch a road, I think we have to be conscious that we've met minimum standards for those kind of issues as well. So that because the expectation of the driving public is that we've met a standard as we upgraded the road. So I think there's a whole bunch of things that have to be taken in concert to do that, and that's where that convoluted kind of flow chart came from, was to think out those things before we got there and did the conversion, because they will all be factors. And there has been, a few major lawsuits in Ontario where roads have been touched or upgraded, but maybe not in a pure engineering fashion, resulting in accidents and multi-million dollar settlements that come out of it. So,
yeah. So the all of those widths and so forth to respect, and then make sure you have the right geotech width, and any other takeaways that we should remember?
Yeah. So now we're talking about converting granular roads into other type of roads, right? Obviously, any one of us in ideal conditions want to drive on a fully, they say the beefed up concrete or an asphalt roads, but we can't afford it. Again, given that there are in the United States alone more than 6.5 million kilometers of roads, that's a lot of roads. How many times from Earth to the moon and back and forth? So there are many other options at our consideration. Like I mentioned to you about bituminous surface treatment techniques like auto-seal. We call them also as part of our holding strategies, that we can actually get like 20 years, 25 years performance from a double layer auto-seal. We have to take advantage of them. But if you're going for those kinds of solutions, we have to stabilize our base. We have to beef up the pavement foundation system. When I teach my pavement analysis and design course, I tell my students that subgrade is our actual road. We're putting all other layers on top of it to protect that guy at the bottom. So we have to do our homework and the fundamentals. We can't just go and put surface layer, which are the most expensive, the investment, without beefing up the pavement foundation system, without providing the drainage and all that. So edge drains, critical for long-term performance. So we have to, consider all these points as we, they go, make these kinds of, the investments.
Thank you. So I'll finish with one last question. We spent the day together, did some networking, had quite a few presenters and so forth, and then we obviously were focused on navigating the low-volume roads. So from your take, from your experience and your take, in closing, what does the future of low-volume road look like?
Heavier loads are inevitable. So we're going to have to figure out ways to, with the least amount of funding, to do the best job we can. And it's like one of the farmers in the boardroom when I were visiting, and I was opposed to the heavier trucks. He says, well, we've got to have the heavier trucks. In my lifetime, the corn yields will be 500 bushel to the acre. Now, if we go back not that long ago, the farmers would bring 100 bushel grain wagons into town. Nowadays, it's semi after semi after semi. Farm Bureau in the state said the next 20 years, this is 10, 15 years ago I read this, next 20 years the yields will double. And that is the kind of stuff that we're all going to be experiencing. And that's where the farmers are saying, we're going to have bigger loads because we can't get enough people to run all the trucks to all the grains.
So I hear we have to adapt. We have to adapt to the changes coming.
Yep,
There's
find
no-
ways of doing it.
Yes. Dr. Halil?
Yes, I agree with this. And, you know, having events like these are of huge benefit for us. So we talked about today, you know, this idea, use of recycled materials. You know, we talked about sustainability, innovative solutions for the challenges that we face in the 21st century. And as Brian mentioned, these roads are only, you know, they say the loads, the vehicles, they're only going to get heavier. But we also need to like have a good communication. Maybe we need to connect with these major manufacturers. It's not the total amount of load that they are carrying. We have to present them the, you know, they say the research findings. So if they can add additional axles and distribute them into a larger area, and there will be a lot less damage. And it's a win-win-win situation. We've done some of these things, like in one of our studies at Minnesota Road Research Facility, one of the, say, the farmers literally took our recommendations and he was able to modify the axle configuration of his vehicle. He did it by his own action because he really cares about the roads. Everyone benefits when we drive on good roads, you know. So we need to embrace new technologies and, you know, so that we can have many more options in our toolbox and have a good communication between, you know, the owners of the infrastructure system, materials developers, researchers, so that, you know, the more of these kinds of, say, the events, everyone is going to benefit and help us overcome the challenges. So we have to work collectively and embrace, you know, the new technologies and new materials.
Thank you. And then, Dave, are you optimistic?
You've known me for a while. You know better than to ask me if I'm optimistic. I'm a naturally negative person. So I think I agree with the comments that have been provided here. And I think one of the issues certainly is funding. I know it's tough to get it. It is a political issue. But I liken it back to when I moved from the GTA area down to southwestern Ontario. And I went from a municipality that was rapidly growing, had 55,000 people, down to a municipality that had 3 times the road system with only 15,000 people. And my grade 8 math kicked in, and I said, well, here's the problem is you want these services, the trucks cost the same, they're paying the drivers the same, the materials cost about the same, so it's going to cost more per household. So there's some ideas that we think, oh, it's cheaper to live in the rural area. Well, it is, but if the people want services, then, you know, there has to be that balance between what service do you want and what do you want to pay, right? And I think
Absolutely.
that's kind of where we're at.
And it costs you a lot more to travel, to keep your vehicle up on a rock road than it does a paved road.
All goes with the level of service. And then, so thank you again. So this brings us to the end. Thank you to all 3 panelists, Brian, Dr. Halil, and then Dave.
All the pleasure was mine, and I learned a lot from you too. But one of the our rock research program very dramatic.
Okay. So you already had a little discussion, thank you. Or maybe we can offer that to the table if there's questions before we go to the closing. Any specific questions to follow? No, we're good. Everybody wants to go home, I think. So what we're going to do is, well, first, before we get to the draw, again, just wanted to say thank you. Thank you, everyone. Thank you for joining us today. You know, it is definitely a good turnout. we, for all the presenters, the people that at the booth and the attendees. I was going to add as well that, we have a small survey, that's right. So there's a survey that will follow that you'll receive through your emails. And then if you don't mind, it's probably a 5-minute. So as you fill the survey, sometimes what's good is that you can actually share some intake of what you would like to see or what you would like to cover, or a topic that affects you and that you're looking for answers. Because as we get those, then we can eventually gather the data and that information to build on it for eventually a follow-up. One of the things too, as president of Good Roads, I just wanted to say thank you to our Good Roads staff. They've put a lot of time and effort into this. I know they worked hard. I've seen the circulation of the, it's all really, really well packaged together. And I find that, I don't know if you enjoyed the way that the presentation with the trees and the pictures. And so we're trying to stay modern and to today's way. So again, for that, thank you to our Good Road staff. Another thing too, just to acknowledge that we were here in this building, and then we were hosted by Liberty North. So I wanted to say thank you to them. They were able to prepare the nice food that we had and all the snacks. So thanks for them. And also we have the technical fellows right here that were finding mics when we were changing my batteries when it was dying. So again, to Upside and Sound, thanks so much for your technical support. So thank you.
All right, let's do the first draw.
So we have quite the thing. Everybody's name is in that wheel. I don't know what you're going to call it, the wheel of Good Roads. And it's not tricked. So what we have, the first winner.
Ryan Ratai? Ryan Ratai, is he here?
Now, if Ryan's not here, then you guys are lucky.
Are you here?
If he is there, there we go. Excellent.
Do we have a... Right on. There you go. Thank you very much.
There you go, Ryan.
All right, the next one.
Good shopping. Second prize.
Cyrus. Is he here? Oh, yes, he is.
Cyrus gets the second prize.
Oh, I see.
There we go. There you go. Congratulations. And
Okay,
we're
one
on.
more.
The software still handles the third one. So we're into our final and third prize. Oh, that was close. Patrick.
All right, we're going to have one more prize
you go,
for the necklace
Excellent.
or the bracelet, is it? All right, do you want me to pick it? Okay, here we go.
Oh, music.
Go down
We have
here.
music. We have drums.
Here we go. Jeff.
Oh, there he is.
From EG. Right on. There you go.
Congratulations. There we go.
All right, thanks. Thanks, everyone, for coming out. Safe travels home. Thank you.
There you go. Enjoy the rest of the day, and then thank you again.